Could you then send the link to the Telco OCP-Telco list?
You bet. I don't think I have that list.
That's it. OCP-telcos at list.opencompute.
Okay.
I thought we would first do some, changing, making us look a little better before. Photo one.
Yeah, we're going to be live. Well, you know, that's something that we,
Sorry, what is it again?
okay, dash telcos at list.opencompute.
At what?
LISTS.opencompute.org. And are you a member of the mail list?
I'm not sure.
Well, we'll know
In order to
in a
test it?
second whether if
Yeah.
it bounces the message from.
Yeah.
If you're not a member of the
I might get it because, well, I work for OCP, so
well, you're
I probably will. So OCP-telco at
another
lists
dude. Yeah.
at lists period plural, right?
Yeah, list.
.opencompute.org.
Yeah.
Okay.
Okay.
At least we think he worked.
Yeah.
I'm not sure.
I'm in my third week, so take it easy on me.
I think we're all in our third week. That's kind of what it feels for us. Let's see. Okay, well, hang on about this yet. So thank you. I'm sorry for the confusion. Our wires with Amber got crossed over the open rack joint discussion. So I hope y'all got stuff out of the open rack discussion this morning. The main thing we wanted to do was to make sure that the plan was there, the size differences were there, because we've had some issues with both of those. Or we've had discussions about it. So that was kind of the, and if you want to know more about it, I'm sure they're going to start talking about, screw placement and sizes and all that stuff. So if you'd like, you can go there instead of our fun stuff here. I mean, we'll get there, obviously. And you're welcome to look at the thing. So, but in any case, one of the co-leads, so we have two co-leads. Brian is the new co-lead with, is it Conwan Lee from SKT. And so he wasn't able to make it today. He has a stand-in, Daniel, who can answer all of your questions that you may have for that, from that standpoint.
Craig, can I ask you
Yes, you may.
a question quickly? I never figured out, when do they take over immediately? Is there a handover? I've never really understood how that happens.
Okay, according to the blog.
Yeah.
And the
I obviously
schedule
didn't read it.
on the blog.
Okay.
They take over August the 1st.
Okay.
Okay? So
I some way I didn't figure it out.
in
I'm a little slow.
in terms of realities of scheduling, our call is the first Thursday of the month, which ended up being last Thursday. So that was the 4th. So they took over on the 1st, and then we had on the 4th. And so on the call, I introduced Brian, and Conwan wasn't able to make it.
Okay.
And that was like, this is the new lead going forward.
Perfect.
In terms of the, in terms of this workshop, it was what, 2 months ago was announced. And so Amber asked for me to kind of coordinate the agenda and get everything ready for the workshop.
Excellent.
And, we'll do the handover for this here. And so,
Cool.
there was going to be some training and stuff that maybe happened, didn't happen, whatever. So I'm kind of filling in, and this is actually Brian's first session, and so we're happy about it.
I'm really supporting from the telco, so we have SK and TT here. So
We're and actually And I'm sorry I don't have an agenda slide, but in the first part, we have Jeremy with Orange, who's going to present on his OCP plans with Orange and what's going on there. We have Tom, who's going to present some AT&T stuff, which for those of you who are new or whatever, haven't got in the flow of things, up until last week, AT&T was our only application for the virtual OLT and then 3 series of actual implementations of that. And now we have our new submission on CG Rack 19 from Radisys, which is carrier grade Rack 19 that I sent out, and hopefully everyone's had an opportunity to look at that. So before the break, we're going to do AT&T, Orange, and then Daniel is going to give a readout on the Seoul meetup. For those people who weren't there, can I give some idea of that? After the break, we then have discussion. I think Verizon, SK, maybe AT&T was going to present on requirements or the items of interest with some time for Q&A, and then following that is the discussion of the Radisys submission. So we'll go through that. So that's kind of the agenda for the day. And I'm probably taking up more time than I would like. I think we had about 15 minutes of time not allocated in this first part, so I just ate that up. But I'm assuming that there'll be time in their presentations for questions and answers. So I don't really mind any order. Whoever's ready, we can try it. And then, is that a VGA or a HDMI?
Yes.
Okay. There you go.
Don't sit there.
Oh, yes.
All right. Oh, I think you got it. Got it. So we'll. Nice. How do you work? Okay, so I'm going to go. Well, hi. First of all, hi everybody. I'm Schutz. I'm with AT&T. I'm one of the domain 2 architects. So my job, my life, my goal, my quest is to figure out how to take the legacy telecom types of functions and capabilities. Big surprise that I'm here at OCP looking for things I can map onto. And you've heard me probably speak in the past around how a lot of the things can get mapped directly to data center infrastructure as it exists today, but not everything. And that there's a need for some additional kinds of functions and capabilities for telcos. They're mostly, and there's mostly at the PHY level. Yeah. So I've got 15 minutes and a cornucopia of interesting things I hope for you that are updates on AT&T's activity with regard to OCP. The one that I'm not really, okay, let me just go through. Here's the agenda that I'm ready to speak to today. It includes a quick update on the Open GPON OLT, a little bit, Amber was talking this morning about reference architectures, and so I've got a little bit of something there that, to sort of get your interest on. And then we're going to talk a little bit about XGS-PON, which are the other 3 specs that you've seen from AT&T. And then just a chart, because we've done a couple of discussions on the phone calls around designing for
telco availability using sort of modern day technologies, and I wanted to allow for some Q&A in that space. So jumping through this, there's the AT&T Open GPON OLT. You guys have seen it. We've had, I guess I've already shared, the chest pounding earlier with, we had an announcement around the field trial. There is the software stack that I'm going to count on you guys to sort of interrupt if there's a question as we go, and then hopefully that works well. So I wanted to sort of bring people's attention to the software stack used for this device for a moment, because when we get to what we're up to lately, you're going to see that we're trying to put extra focus into developing a variation of the software stack that would make sense in an OCP environment. And so, just like with the top of rack switches, in fact, this should look pretty familiar to people who've looked at the software stack from OCP from network, right? We have the same basic issue, and that's that there's typically a proprietary library that's associated with each individual instance of silicon that you might use at the bottom end of one of these devices. And we'd like to have as much of the software above that to be flexible, in other words, only loadable, as well as open as possible. And so one of the things that we're looking to do is to find a community of interest who could be willing to sort of work toward creating as much of that software infrastructure in an open way as possible. All right.
Tom, so today, does it use ONI in something like ONL, or is it stuff that you guys have sort of cobbled together to make it work for your purposes?
That's a great question. The question was, how much of the stack does it use today from OCP? And so it does have an open Linux. Right now it's Ubuntu, it's not ONL, but and it worked, but we had to get there, right? So it was sort of expedient things on the path. And it doesn't do ONI right now, but that's something that we are interested in it doing. We're interested, as you'll see in a minute, to sort of go in the direction of OpenBMC and to see how close we can get the operations and management of the GPON box to look like a plain old top of rack device, right? So we're going to be looking into the IPMI kind of, what could we pull out that's in common, and so forth. In fact, that's almost my next chart. But the thing that I was going to point out on this chart, and I'll come up again later, is we think that there could be an interesting definition like SAI. SAI might be too much just for switching silicon. We might access SAI or ASAI, I don't know, whatever, or just expand the definition. But we're very interested that the work that we do above the silicon layer gets to be reused easily over and over from one design and one silicon manufacturer to the next and to the next. Okay, so just a couple of small points. The GPON spec went up to the IC, and there were just a couple of things they caught. They were good catches, by the way. There were a couple of places where we had said x86 when we really meant whatever CPU you choose to plug into this device. And they also did some good sort of pounding or suggesting that, espousing the OpenBMC and the IPMI was a good thing, and we bought into that really well. All right, so gear shifting. What are we doing with this? And part of the thing that you saw in the previous charts was a link to the field trial. We have a reference architecture, and so this Open GPON OLT is used as part of a pod of equipment, and that pod of equipment is essentially all OCP, not the rack, I'm sorry, but there are servers, there are switches, and there's this GPON device that are all part of this. Is it listed here? It'll be in the next chart. And then there's a whole software environment that's being built on top of this that we're working in conjunction with the Open Network Lab and calling Central Office, re-architected as a data center, or CORD. You might have heard about it. We've had a first kickoff. CORD is now a Linux Foundation project. They had a kickoff at the Google headquarters just a few weeks ago, and they've sort of built a roadmap on where they'd like to take it. It's a lot like an OCP initiative in that it's not a standard. It's people who like, careful definitions probably wouldn't call it a spec. It's like a reference implementation, right? That's what we like to call it. And it's really useful in that regard because it lets people build in this direction or in that direction. It's not made to constrain, it's made to accelerate market velocity. And so one of the things that we got out of the kickoff meeting were where people wanted to take the core architecture. And as you can see, there's a list of access technologies that people were interested in integrating and pursuing in that reference implementation that looks like it could be good hints at what might be coming into the OCP in terms of access technologies. What is a cord pod? It is, I don't know if that's even readable. I'm sorry, I pulled it from a different chart and I'm not going to complain. It is, what you can't see there is that there's sort of 3 white box OLTs. These are the AT&T Open GPON OLTs. There are 4 servers there. You can read that at the top, right? They're the Quanta S210s. They're OCP spec servers. And they get connected into 4 switches at the top, which are arranged as 2 top of rack and 2 spine. But they're all the same model. They're all Acton 6712 switches, which are 32 by 40 gig. And they're used both for the links into the rack as well as the links into the spine. So this is the pod we've defined for development and test, and is also being used in the field trial. And what happens is we use 40 gig interfaces in the servers. The AT&T Open OLT, as you might recall, has 3 + 3 40 gig uplinks. And so using that one kind of switch both as a TOR and as a spine made a lot of sense in a pod. It's not to say that all pods have to be like this. And in fact, we're kind of working on a really small one that could make it much easier for people to develop software without having to deploy as much hardware. Okay. So I'm ready to shift gears again past the reference architecture to our next set of specs and sort of what we've been up to. Yeah.
Real quick on your on the S210s, are you using 40 gig interfaces?
Yes.
There as well?
Yes.
Okay.
Yes.
Is it a single 40 or is it a dual 40?
It's a dual 40.
Okay.
So
Do you run that active standby or active active?
it depends on which NIC you use now, doesn't it? Because we've tried 2 different NICs in that we've been doing some performance modeling. And the first NIC that we used was really good because it was well supported from a firmware perspective and a lot of GPDK and whatnot, but it only could light up 140 gig interface at a time, essentially.
Is that because of the 8-lane PCI Express limitation, or was that
No,
just?
I think it was a more fundamental card design limitation. It was we tried a second NIC from a different supplier, and we found that we could bring out both of the 40 gig interfaces simultaneously. So, so it depends is the answer. That we've been kind of playing around with the NICs, and they're not. I'm not going through a long tirade or anything, but your mileage can vary with the choice that you make in that space.
I'm just curious. That's a problem I'm struggling with now. Is really the PCI Express bus is becoming the limiting factor as you increase your interface speeds.
Yes, and we found more problems with the servers than the NICs in that regard. That some servers we looked at had sort of fixed PCI to chip lane configurations, and they were not always optimized for doing I/O, especially when you had 2 different ports on one card. Like if you had another card, it was good to send to a different socket, but not, okay. It was maybe the same problem you were looking at.
Yeah, it depends on whether you have if on an 8-lane, you can't get dual 40 through.
I think it's 63 gigabits per second. Is
About 60 through 60 good foot. But on a 16, if you have 16 good cards with 240s, you should be able to push it. If you have a server then that has 2 16-lane PCIs available.
Right.
Hopefully the different CPUs.
Hopefully
That's
the
another.
different. Well, no, that's the issue too, because generally we're interested in putting in one card with 2 ports and getting half the links to go to each socket is kind of interesting.
I think we know, talk about that.
Yeah, that could be fun to talk about, actually. So, yeah, we do, we haven't come here with that kind of information, but we've been doing quite a bit of looking at how to get good performance out of data center infrastructure for telco applications, right? We've been partnering with folks at Berkeley and Intel, for example, on some of the work. Okay, so moving ahead, the next, I gotta go back. Next section of my talk is about our XGS-PON OLT specs. So we brought them in for the first time. Not sure if it's well known or not, but the merchant silicon for XGS-PON is sort of an emerging thing. It's coming out this calendar year, but it's not something that was that easy to get our hot little hands on. And so what we've done is the feedback that we've gotten off of GPON specs that we believe can apply well to XGS-PON specs, we're going to bring that in. We've been focusing a lot of the work that we've been doing on the software architecture, and I've already alluded to that we're really interested now in kind of a common software agent infrastructure that could be used and reused from one box or one platform to the next, and from one silicon to the next, and are looking for developing a community around that. We would expect that we get some inputs on what works and doesn't work with the emerging silicon in the fall as we get our hands on more of it, and that we'll have updates to the hardware spec at that time. Now, here we go. I've already kind of alluded to this earlier. We're pretty much set on going toward ONI and the OpenVMC as a direction for these kind of boxes to make them look as much like a top rack as possible. There is interest in looking at the SAI API, and does it make sense to access silicon? And how would we modify it? Would we fork it and create a parallel path? I don't know the answer, but it'd be I think it's an area we'd like to pursue. And of course, we're bringing this out, like Amber says, way before it's done, right? The silicon isn't even completely available yet, and are looking for input and feedback. We think it makes a lot of sense that many carriers, many users can make use of this spec, and we're very flexible about how it moves forward. Okay. And then lastly, there is the technical spaces spec. There's a link back to our spec, our TRs or TPs on AT&T's deployment practices. And so the things to say, we have a variety of different services that we sell. They range from 2.5 nines to 5 nines. But what we find is that 5 nines is really much more rare than it once was, and maybe never was. So that, and we talked a lot. We talked a lot about 5 nines for a lot of years, but most people are very happy with 4 or 3 or even 2.5, right? They serve many customers economically and well. And one of the things that, as we move toward data center infrastructure to support telco services, we don't want all of the infrastructure to be built simply to be able to support the 5 nines services, and then you pull through that cost and expense and design complexity for all the other ones as well. So very much our mindset is around build to a common platform that is a little bit less available, and then use software and duplication techniques to provide more availability and resiliency on demand. And so that means we've been looking very strongly to being able to release some of the pressure that was applied in traditional telco net specifications. And the way that works is, I'm repeating myself now, so if you start glazing over or looking at me, I'll try to speed up. But generally, the way that works is safety is paramount. We're not really budging on safety, either human or fire safety or any of those other things. But the typical resiliency requirements have a certain mindset to them in NEBs that we can revisit now. And so the total availability we expect out of a box changes from sometimes to another. If you've read ahead through the bullets, you'll see that, you know, when we have a box that gets placed in a point where it is a single point of failure, we're going to rely on that box to be fairly available. But in many cases, like fabric or like servers, not one single box is involved in a single point of failure for a given customer. And so for those kinds of devices, we believe that we can and should accept equipment that's much less available on a per unit basis. All right, and so the chart was here. We kind of introduced this on a couple calls, and I don't know if everybody got a chance to hear about it, but it was mostly up here because we never really got through. I remember a couple of calls where we made it right up till the very end and no one had a chance to ask any questions, and so I wanted to give people a chance. So with that, are there any questions? I'd be happy to answer if I can. Or if you'd like to go to the next talk, that would be great. All right. Thank you very much, then.
Thank you.
I call that a clean getaway.
Hey, Jeremy, on the top of that screen, there's a button for PCA or HDMI.
Okay.
So whichever one you need.
Yeah.
Hello, everybody. I'm Jeremy Rebel from Orange. I actually work in San Francisco for Orange. I'm part of a division is in strategy and innovation for the company. So I actually test a lot of the products available in Silicon Valley and the US for the company, typically early in the stage of the different companies that we test. So sort of an R&D work, if you want, and so I've been using Open Compute since the beginning. And E1 and V2 servers, the original rack. We've done some early tests there of integration of software. And we have an open rack as well with different vendors. We also have designs that never made it, that were compatible with open rack. That we've tried specifically for storage.
Can you speak louder? We can't hear you.
Oh, set my let's do that.
It's a French accent.
What did you
We have to
miss?
deal with this
Everything?
always in Germany.
So I'm from Orange, but I work in San Francisco instead. And so I tested Open Compute since the past 4 years, I guess now. And we did 3 different integrations in San Francisco of OpenStack, 2012, so very early versions of OpenStack. I'm sorry. I'm very sorry for myself. Thanks, Tom. But that helped us to understand where it was in terms of integration, how the vendors were reacting to software, to hardware that was not manageable easily. That IPMI was not the right version at the time. Managing firmware was there. Changing BIOS configurations was possible sometimes. So that was a good way for us to understand where OCP was and if we should push it to production or not. So we still have the hardware, we still use it. We just decommissioned the last OpenStack to the cloud on it. We are moving to a lot of Docker-based systems now. And but the company is starting to be more involved in Open Compute because it's mature enough for us, I think, to start to contribute. Some of our thinking that we've been doing around data centers that are not related to Open Compute, really, because we don't use it in production. But we want to exchange, see if we could really debate on different ideas and see how it goes. So what I'm going to do now is just present work that we can submit. There's one that is more mature than the other, one that is coming up, that is very early, and one that I'd like to propose to the room here that I mentioned a little bit earlier today. So We go over that. So the first one is data center design related to the power. We've done some work at Orange in the past years on 400 volt DC in the data center. We'd like to contribute that and see how people react to this and how we could integrate what with the existing rack designs that exist now and how it would be valuable to others. The scope is that it would run for data centers, but it would run also for our small central offices where we have less racks, but where I think we may have also 40 volts as well there. And one of the interesting part of that specification, if you or guidelines, I actually would call that more guidelines, is that it relies a lot on standards that exist. And some of them are European standards that we have at Orange. And I think it's fairly new at Open Compute. There is not, I haven't seen any specs that relies on European standards. So just a disclaimer, I'm not the author.
That was 400 volt DC.
DC.
Yeah, DC, okay.
In the data center, not in the rack.
Right,
So I will
right.
clarify that.
Okay.
And one disclaimer, I'm not the engineer that worked on this. So I collaborated with my colleagues for the past 6 months to start to publish that and understand a little bit what they are doing. If you get really deep into the questions, I'll be lost. So I will rely on my colleagues when they're going to present that to the IC, hopefully in the coming months. But feel free to give me the questions. If I can answer, I will put you in touch with the right people.
Okay. I knew 400 AC is a fairly common
That's,
voltage in
that's
Europe,
DC.
but then it's actually DC.
Yeah.
Okay, let's make sure, yeah.
Yeah, for interest, I know that Lawrence Livermore did a lot of work, I think it was on 380 volt DC. And there's a fair amount of information if you Google it.
So it's actually both at 380, but the spec goes up to 400. So I asked them to suggest 400.
And
There's
does
commercially available 380 volt distribution. Equipment.
Does Orange use 400 volt DC in France in their normal POP locations right
No,
now?
I go over that in terms of maturity where it is for us.
Because I thought we were all using the 48 right now.
We have 48 for the equipment.
Yeah.
Has some advantages. It's sort of lower resolution here, but it's okay. So the scope here is, so you mentioned the building, the data center. You have all the conversion that is being done just to convert from the very high voltage that you get from the grid to a lower voltage in AC. And then after that, we're going to convert to DC, but at the same higher voltage, more or less. And so the scope is really that dotted box in the middle, up to the power supply next to the server, potentially. So it could end at the rack, it could end at the server itself, depending on how you implement that spec. It doesn't include the other sources of power. You could produce DC from the solar panels, and that kind of things. It's not included. It's mostly on the rectifier, the specs of the batteries, and the cable. It's mostly what it costs. So that I'm not really literate enough to really understand the details here, but it's one way of implementing the spec. And the spec is open enough to have different ways of doing it. So here we use the generator outside, which is outside the spec. It's just a traditional diesel. And how it's plugged to the DC grid, but you could do it differently. So as far as I've seen in the spec, you can see that in the details. I'm just going to go over the overall thing, why we are interested in that. The pros are that it's by nature it's higher efficiency in general. You're going to do less conversion, and it's better at the end. You will never go from like AC to DC to UPS and then to AC again to the rack and rack to DC again. It's the most the whole chain. You convert basically once or twice. But, it's safer than 48 volt. So we have 48 volt DC in our data centers, and the problem is that it's very high current, and it's sort of dangerous for the human being. And, so that's better as far as I understood again. The cables are way smaller. We can use the regular cables that you use for AC, so that's more actually. And instead of the big struts that we have in the data center for 48 volts, like that thing that's massive in the data center. Here we would basically even reuse what we already have in place, if we want to. You don't have to do phase management because there is no phase. So the stuff that we do in Open Rack with the different layers and all that, you have to deal with that. Overall, it's usually a simpler electronic to do a DC. So they break less, they cost less, and at the end they become more reliable. And overall, you save money, OPEX money. The batteries in our design that we propose here, the batteries are in a different room that we do in a traditional data center, I would say. So that would fit for a server room where you have a raised floor, which is what we typically have here at ONH. And the batteries are very heavy, typically, and they've got too much constraint on the way we design the racks. So you would keep the batteries in a different room. And since you keep them in a different room, you can also operate them at a different temperature. And apparently, batteries prefer to be in the cooler environment than servers. Servers can run at the high temperature today. That makes them more efficient. And you can keep them longer this way. There is also a transition from AC to DC in the guideline. So if you have an AC-based system now, you can start to plan for the future and how to move that new architecture. And again, as I said before, it's leveraging standards. So we are not reinventing the wheel. It's guidelines and specs and stuff that exists tested by other people around the world. Actually, 400 volt DC, as far as in the literature. I know it's not very new, it's not very old, but it's at least 10-year-old minimum, and it's been tested by many people around the world in data centers, way larger than our data centers. In terms of maturity, it's not common in server rooms, but the new technologies that we're more familiar with now, the solar panels, the cars, they all have DC systems. All the electronics is DC based, so we can rely on the vendors of those technologies potentially. So the components are available. The power supply that my colleagues used are actually just coming from the traditional power supply vendors. They use non-OCP gear, so they use like HP and IBM servers at the time when they did the test, and they just asked them to change the power supply. I think it was Emerson, it was one of the providers of the power supplies. Just had the same form factor and they plugged into it, and that was working fine. So where do we are today? So we did some tests in France, in Vélizy, which is next to Paris. We did some tests in Brittany as well. Using off-the-shelf hardware. As you can see, it's very small scale. I think they did a slightly bigger one in the data center, but it's very small, but it's working. They did a publication at the IEEE a few years ago. And we started to do the draft for OCP. We shared it with some of the people in OCP. So that's still early. And we are looking for potentially people to help us to actually do more tests in Europe. And so in Europe, we look for hardware vendors that could help us to get OCP gear that we can play with, or maybe a room where we can actually test So that was the first one. The second proposition that we have for OCP is really early for us. It's we did some work on water cooling to the servers. We'd like to contribute that to the community at some point. I expect that's going to be done later this year at the draft level. We did the same approach to traditional vendors like IBM in that picture, blades, and we modified them to adapt it to what we could. We had some paper that's been shared with the world on how we did it, which vendor we used, and now I'm working with my colleagues in France. It's actually almost the same team that did that for the PC, to adapt that to OCP gear. And we have the same issue here. We need to get access in Europe to OCP hardware that we can tweak. Like the rack itself, how do we run the pipes through the rack, and where do we put the exchanger, all that kind of thinking. I want my colleagues to actually be able to play with the hardware. And how they have a constraint of not being able to buy so much hardware, so we want to partner with somebody.
Jeremy? Are you cooling just at the rack level or actually at the server level?
Server down to the CPU.
Down to the server.
The paper actually talks about the CPU, the memory, the drives, and the EEPROMs.
So this is directly thermally attached, not
Yeah.
air exchange.
So there is the traditional water cooled heatsink that you have on top of the CPU. And then the pipes will go out of the rack. The exchanger is mid-row or outside, depends on what you put that. So that's the thinking we have to do. In they'll test the exchanger whether you're in the same room.
So when you have this contact cooling for some of the components, what do you do about the other components? Is there also some traditional cooling for the other components that aren't picked up by the direct contact?
From what I've seen on the paper, everything was water cooled.
So when
On the
you use
motherboard.
big plate for the whole thing?
You had those water cooling sinks on the CPU, the memory chips, but also on the drives. And on
But what about other incidental parts, the NICs, you know?
the NIC was covered, I think, if I remember correctly. But the paper is there, but I think you have to pay for it.
Jeremy,
I had a copy, but
do you know if there was a cost analysis done? I mean, you say it's efficient.
yeah, they've done some. It's R&D people that did the test, so we don't have operational numbers on how more efficient it would be to what we actually run on Orange. We don't run water cooling, we don't run eBay, we don't have that. We have a cool system very similar to Fire, and that's it. There's no water allowed in the data center, so they will not able
Right.
to upscale.
As you just said, no water allowed in the data center.
This one,
Safety, those kinds of issues.
I haven't seen anything about that. So that's the second one. And the third one is the one I just want to propose. It's not something that we do in production either at Orange, but that's the point I was discussing this morning where OCP is struggling to get adoption, and especially from maybe smaller players. And I can consider myself as a smaller player because I have a small lab of 16, 20 racks in San Francisco, and getting a little bit of gear has been pretty interesting experience. Even if the venues are very nice and we've tried a lot of things, but at some point you have to spend a lot of time with stacking. And that includes the hardware, but that includes also the software side of the problem. What I would like to do is have some of an integrated solution of some sort where both the software guys and the hardware guys are like winning that start. Because if I bring OCP hardware because of costs and energy concerns, my software guy, it's going to be painful for them today. If I bring new software to the OCP vendors that I have, they're going to say, okay, we don't do that. We have our own stack, integrate our own way, we do our own benchmarks, and all that. Why don't we agree together? And I think OCP could be one forum to do that discussion. It seems like there's an interest. This morning, a lot of people talked about the manageability of the hardware. This is just one proposition I'm doing because I do a lot of Docker-based deployments. So at the foundation, you will have different type of OCP gear, and I include everything: server and networking. You will have a stack that will do the PXE booting and IPMI and management, like the lower layer, maybe even the firmware management. So some of the open source software available on the market can do that. The logo here is something called HD, which has been offered by EMC some 3 months ago. And they manage PXE. They said that they could do ONI, they don't do ONI today. There are other options to do ONI, actually. Then use Docker for almost everything in the operating system. Sort of, Docker is installed by default, the same way you install Linux by default in that stack. They would just come with it. After you need a layer on top to manage more than one node, because the data center is not one server, it's thousands of servers. You have to manage them easily. Docker itself could do that, but I've seen like a solution like Rancher, which is also open source, could be a solution for us to manage the hardware entirely from top to bottom, and also the middleware on top. The Kubernetes cluster, Mesos cluster from Rancher down to the bare metal. So you can say, I want a new node in my Kubernetes cluster. it's going to ask RackHD to create a new machine. That machine would then do provision with money, and potentially RackHD would ask I mentioned Snap around here, but some kind of KPI to the network to configure the ports.
So we're using Core OS with this?
You can use CoreOS. I mentioned Docker here is sort of the trendy logo, but some kind of containerization where we don't have too much virtualization involved.
Yeah.
Or basic functionalities. So it's a proposal. It's something I'm going to try in my lab. Those vendors are already relying with me to do an initial test. It's fairly new. If there's somebody else interested to drive requirements, let me know. I'm going to use the gear I have so far. OCP based. That's what I had for you.
So for the last, sorry, the last one is you're kind of putting a concept up.
Yeah, I think
What
frankly,
you'd like to do, but you don't have a
it's not working.
proposal.
No, it's basically the work that we've done with OpenStack many times. I don't want to use OpenStack anymore for different reasons. Not that I don't like OpenStack, but I think it's not efficient for some of the things that I want to do here. It's not mature enough, maybe some of those parts as well. And it has some legacy. I don't want to see it in my computer. So we can do a lighter stack. And I'm looking for not help, but somebody that could work with me on putting together requirements for that. Because otherwise, they're going to just come from my small scale lab.
This might not be related to the subject. Maybe you can provide some information regarding the operator. How do you see like OCP kind of architecture or the port architecture for that matter? How do you see that solved from the operator and what time frame?
It's not there because it's not still discussions that are ongoing. And Orange is a large company, so you would hear one thing and you would hear another thing elsewhere in the company. Because we operate in different countries, and the different countries are independent from each other. So France may be interested in OCP today on the compute on that, and Spain would say no, we're going to stick to vendor, and that's it. So there's not an official Orange position. That's one thing. But the R&D division of Orange, which is at the group level across the countries, is doing collaboration with AT&T and Core. We work really closely with them. We have our own lab, in France. There is an interest to run some of that on OCP hardware. It's early, and it's not because of OPNFV that they want to do it. It's because Orange is part of OCP now, officially as a board member, and we want to see if the existing work that they were doing in OPNFV fits the whole compute. Not because of a strong interest in operations, just to see how it would work. We are at that stage now, trying to figure out who can do that at Orange, when, where. So it's interesting. But that means open. If I understand correctly, OPNFV is OpenStack based today, mostly. So that would mean not that. We're using OpenStack vendors that are doing OPNFV ready stacks. And I may be the one in problem.
Orange has been a very early to deployment of like IPv6, and well, not very early, but less tentative than others have within their own infrastructure. And obviously, I mean, I've noticed there's a lot of stuff out there that still is being developed as if we live in an IPv4 world. And I'm curious if part of the goal here is build something that is from the ground up, IPv6.
It doesn't come from the mothership, it come from me. I actually bothered the 3 different integrators I've worked with on OpenStack about that. We talked to an OpenStack vendor in 2012 that you want everything to be IPv6 based from zero, from scratch. You get doing it really here. You never test it. If you deploy OpenStack today, it's not even the case. It's not IPv6 ready because it's not tested. It's not that it doesn't work. The second deployment that we've done was IPv6 ready, but not up to the virtual machine because Neutron was not tested properly with it. It was not going deep into all the layers. So they were saying, okay, we don't expose it to the VM, so that's the point. This is where you need V6 at some point potentially. Using V6 in the infrastructure for me was really interesting because I think it has to be there to automate everything and remove the human being completely from the picture. Automation should be done mostly by the machines, and the best way to do that is with IPv6 because the human being doesn't want it ever. And if you make everything IPv6 based, you never touch complete back, ever. That was one of my interests. And we've done some tests. The network fabrics, like Cumulus is IPv6 based, easily, you can also make everything with that. But Orange, I'm not the one working on IPv6 at Orange. I don't know where we're pushing for it. Orange.com, orange.fr. If you go to it, it doesn't result in IPv6. It's really
I think we're gonna be a little late for our break. Let's see if we can get this one in before the break. If you don't mind. Do you need, are you doing HDMI or VGA?
Just seeing.
Okay, so on that screen right there, push the button that says VGA.
Okay. Hey guys, this is possible. I mean, what's okay, I go. Hi, my name is Daniel Chang. I'm working at SK Telecom. My department is R&D strategy, and Gang Lee, the new co-lead, along with Brian, the Telco group, but he cannot make it for today's meeting. I'm kind of a delegate, as you know, as to represent him there. So today I'm gonna talk about two things basically. One is a recap of the meeting we had 2 months ago, actually, 9th of June in Seoul. We called the Telco operators meeting, and I guess there was some concerns about the meeting I heard, and I'm here to clarify that. The meeting was kind of private. we only invited those Telco members within the OCP groups, and then might cause some concerns amongst yourself. The reason why was because SK Telecom ourselves didn't quite know, what the scope of OCP Telco group was. Since the group started earlier this year, we didn't actually know where to start and what kind of scope we should be covering. So we had thought that among the Telco members, we discussed first to where to start and discuss about where to go, towards what direction, and so on and so forth. So hopefully today's presentation might clarify some of those concerns. Okay. These are the pictures taken from the meeting. You can see that everyone is smiling on the left picture. In Korea, when we're taking pictures, we say kimchi. Kimchi is a famous spice Korean food. Some of you might know. And,
we drank some alcohol before that.
we served beer. So because of the pronunciation, kimchi, it's just like a cheese. So everyone is smiling, smile there. And on your right, we are showing two servers we have developed on our own, SK Telecom. The AF media streaming server, and the other one is TCAP, the switching server. And they are quite interested in these two products. I will explain those two in the later slide. So these are some overview of the meeting. It was held on June 9th, and full-day meeting. I was in SKT headquarters, and the attendees were Verizon, Deutsche Telekom, EE, Facebook, OCP Foundation, and also SKT. Total of about 12 people attended the meeting, and the meeting was, as I said, for the telco operator. So there were about 5 key topics in the meeting. Verizon talked about the requirements for implementing OCP at Verizon, presented by Brian here and Gagan. And they gave us some updates on the OCP requirements regarding the NAS and also the management software, and the way Verizon thinks it should be handled within the OCP community. This discussion will be further developed, I believe, during the panel discussion we'll be having afterwards. And then Kang Lee, he presented some of the activities SK Telecom has been doing and is doing, and I'm going to be covering that as well after this presentation too. And Mansoor from EE, he presented some of their activities in rural connectivity and disaster recovery and edge computing. We at SK Telecom then shared our experience and thoughts, on implementing these OCP hardware and then solutions, especially on the virtualized IMS and virtualized brand, and for the POC that is ongoing right now. We also demonstrated some of the data center solutions and OCP hardware solutions, all developed by us. So to jump to the conclusion of the meeting, after this presentation and demonstration, we had an open discussion to discuss about the scope of OCP Telco project group should be what we think it should be. And I think it's still an ongoing process. We need to some extend some clarification on those points. But we came up with this statement. As you can see, data center is just part of the OCP telco network, and the scope should be covered in the network, from the data center to the edge of the full network architecture. And this discussion has been reflected in the charter, thanks to Craig here. In the section, key project focus areas, as he says, transportation IoT-based communications, for example, high-speed trains, airborne or shipborne equipment, and any type of computing that pushes data center functions into a telco network that may evolve in the future and that may not be part of today's network components. These are all inside the scope of the telco.
Just for clarification too, the first statement actually is in the section above it. So that was all incorporated into the charter on the update. That's the latest update.
Okay. So the presentations from Seoul meeting are downloadable on the OCP wiki, and you see the link there. That was about the updates.
And actually, I remember that the first one made its way into several different places in terms of end-to-end management capabilities, which joined in with some of the other requests we've already gotten, and a uniform interface for those management. So for the hardware to have that uniform management, we'd be able to contribute. So it actually got broken up into a couple, but with the end-to-end concept put in there, that it wasn't just the data center, but incorporated the wider. I think I may have used service, the ability to use a telco service rather than the same network.
Yeah, exactly.
Thank you for that as well.
Thank you very much. Any questions before me? Okay, jump to the next slide.
Although, I think Brian commented on the IoT. Did y'all follow that discussion on the mail list by any chance? I was kind of looking for you guys to kind of to do with your topic. I'm not sure how we wanted to handle that, but I was good with his wording. That captured it.
Yeah, I saw the thread, but I'm sorry, I couldn't follow on that. I think it's a good discussion. We will be handling actually two things by Brian this afternoon to improve this discussion. Might be a good idea. But major topics will be next requirement, the other major software requirement. Maybe you can add IoT stuff in there.
I just want to bring that up. Good.
Yeah, I guess come up. Next presentation is about SP Telecom's vision towards the all IT infrastructure based on open infrastructure. As we all are well aware that the network and IT are being converged with no more clear boundaries between. And telco infra is evolving to all IT network by technology, with like the smartphone. So it evolves to feature phone and adding some computing processors. So how it's evolved and what is evolving. So the same thing will happen, we think, in the network as well. The keywords of this evolution is programmable mobility, scalability, and service opportunity. And we first saw this evolution started in the data center, and it's now happening in the mobile network. So with this evolution in mind, Telco have designed the next generation infrastructure and named it as Cosmos. Cosmos being composable, open, scalable, mobile oriented. And when we were designing this, we had some, and the first 3 words explain this rule. It should be composable, it should be open, and scalable. It is also our belief that these keywords, these ground rules should be applied to OCP as well. The Cosmos is based on open hardware as its physical infra for its server, network, and storage, all can be provided by OCP. On top of it, we have the open software as its virtual infra. For example, OpenStack for virtual machine and Docker for container, Onos for SDN. On the application layer, we will be running telco services, platform services, and the orchestration, provisioning, and monitoring, all provided by open source solution. As we are designing this Cosmos, we felt the necessity of clear definition of the requirement for open infra to be used for the NFV. It should be, we have 4 points explaining this requirement we think it should be applied. It should be optimized for performance for the Telco network, Telco workload, and it should cover the novel architecture for 5G era. And the design should be smaller and more distributed. It should be feasible for the more distributed. And it should be calculated, reliable, and safe. It should also adapt to the requirements that we have as far as the safety goals, such as NAPS requirements. Next slide is I'm going to explain some of the activities we have been doing as for developing solutions for open hardware that could be contributed to OCP community. First one is AF Media. AF Media is high performance, high density, all-flash storage server optimized for media streaming, and this is using the SK Hynix 3D NAND, latest one, and it has ultra high throughput, which is optimized for UHD and virtual reality streaming. One of the use cases we have here is that SK Group owns a baseball team called SK Wyverns, and we also have a stadium, baseball stadium. And inside that, we have this huge LED monitor that is size of roughly 3 basketball courts. It's huge. We claim that it's world's largest LED. And you see the contents to go through is humongous, and the streaming server that could handle there's not many out there. So we've implemented our AF Media server there in the stadium, and it's working great. So as you can see, the footprint is just one new site. We have 16 SSDs. It's only 1/20 of hard disk-based servers, and the power consumption is very low. It's under 150 watts per system module. It's also 120 power consumption than ordinary hard disk servers. As we speak, we are writing the specification to be contributed to OCP community this month, and hopefully it will be accepted, and by the end of the year or probably next year we'll see this as OCP accepted.
And just maybe a too detailed question on your SSDs, kind of interest to me. Are you basing that on SATA interfaces or PCI Express interfaces?
It's a PCIe Express.
So it's PCIe?
Yes. Next one is Embrick Array. As you know, this is JBOF device, just a bunch of flash. And it's just like the Lightning server that Facebook has developed. Actually, we are cooperating with Facebook on this product too. Some of the parts, OpenBMC and retimer card and so on, like that. We have designed this server for specifically for 5G storage. Because of this high IOPS, low latency, low cost per gigabytes, it could handle high demand created by these 5G applications. It's high in scalability, flexible allocation, and operation is continuous due to its support on hot swap functionalities. And one of the key features we have is it's a PCIe direct link from CPU to NVMe SSD. So there's no protocol transition overhead. So basically the design concept is the same. We have very small footprint to cover 20 NVMe SSD up to like 80 terabytes. It's high, and reliability and availability is very high, and also support the OpenBMC and multi-host connection. We can support 6 hosts at the same time with 8 gigabytes per second throughput for each host. This particular server is being expedited at this moment in Santa Clara Convention Center. There's a Flash Summit going on, and actually Kang Lee is attending there right now. So this one as well will be contributing to OCP within this year.
So these 6 host connections, are they, I assume that there's a thing in the JBOF that allocates or distributes those among the drives so that any of those can access the drive?
Yeah. Next one is the switch. Switching server, another open hardware we have developed. It is converged network appliance, integrating high performance server with data center switch. Use cases, we have like 3 of them listed here. You can use in core switch as a network applications, both balancing, firewall, and so on. We can use it as a data backup and network analytics. And also we can use overlay gateway for virtual. We are also contributing.
Is the switch silicon defined?
Switching silicon is Intel's the Red Rock Canyon.
Are there external information switches?
External connection.
The switch has external ports.
Oh, yes, we do have an external connection. To provide some more detail in live. we have the specification sheet for this.
Oh.
It's only this. And we are doing OCP trial, the POC, that's scale OCP trial. We're doing it in two phases. First one to verify OCP benefits like power saving, or better cooling, higher density, cost reduction, things like that of CFP. And we are going to deploy this in the Telco data center we have. And there's one concern actually right now because of traditional power side at the limit, roughly 30 ampere unampere. And OCP rack has 6 ampere. So we are not sure what to do with UNH. So we're trying to see if we can use actually the OCP rack, open rack, in the transmission side, limiting only 30 ampere. We use some servers that leaving some space open. And various things we'll try. We'll maybe try to modify the data center to supply more power, but the cost will actually go up. I don't know if you can change all that. So after the trial, we'll share the results. So this slide explains our vision for the open infrastructure. As you know, we are a gold member of OCP and recently elected as co-lead for Telco project with Verizon. And also we are active in TIC project too. We are founding member of the TIC, and our CTO is chairman of the board. So all these activities is because of our belief that this all IT network will be happening soon, and will have to be well prepared for these changes. So conclusion: SKT is now co-leading Verizon in Telco project group. Next generation infrastructure we have developed is Cosmos. It's based on open source hardware and software. We will open and contribute all of the solutions we are developing under open hardware categories, Embryo Array, AF Media, TCAP servers, to OCP community. OCP trials are underway, and we'll be sharing the results too. And we think that Telco project group should be active in leading the whole OCP community and defining environmental physical requirements for Telco data center, as well as for management software and more. So that's about it for my presentation. Thank you very much. Any questions?
But you're switching server. With all the talk about disaggregation in the data center, why do you feel that this is a good design?
Well, because it saves you space. Actually, when you are implementing servers and switch, in separate way, then it's actually more than half a rack. Right? But this switch can actually reduce this into one single device. That's what this idea came up. When this idea came up, that was the main purpose of designing this hardware. But what we are not sure at this point is that actually, in commercial wise, is it going to be viable solution? We don't know yet. We're trying to find out. Yes.
Yeah, Daniel. Can you describe the OCP SKUs that you're using in your test labs today? What products you're using?
Oh, we are using the servers from within, switch and server from within, and the products I explained, the TKX switching server and the AF media server we have developed. Envoy Array is going to be and the POC next month or the month afterwards.
So these are the switch and server. I guess the server would be in a standard UNH 21-inch rack.
Yeah, that's right.
Okay. It's like the 7220s, I think, or the model number. You know the model number?
Not sure about the model number. I will check.
Okay. And then you're using a. I don't. Does UNH have a switch? OCP switch?
I believe so, because that's what they. Well, we have two vendors actually. I'm not quite sure if the decision has been made, but it's a POC, so we'll anyway use the others too. But we will certainly have provide us server switch, and then rest of them we will use our own, and also the rack itself has been provided by this.
Okay, thank you.
What's that?
This is good.
Anything else? Well, I think we have to take a break, right? Thank you very much.
Thank you.
Oh well.
Oh God.
Already getting used to sitting.
Oh no. Yeah, I have that long flight tonight. I'll lay it down.
At least there's break. About an hour, so hopefully 50 minutes to.
Yes.
Thank you very much. How are you? So there's a break. 15 minutes. Yeah, it's not long. It's like it starts back at 3. Well, I should have heard. So hey, break. We'll be back.
There'll be about a little bit of a break, and we'll come back at 3 o'clock.
So you've got so you take so
Yeah, I remember Alex Secure. He writes a lot of names.
all over my desk.
He was very It's not all of you. There's still running OCP. They check our file plans. It's just how the other participants vote them in. So, sure. Yeah. So, I was the one. And that's how it is. And it's pretty good though. There's also an ability to bring more pressure on the film labs. They might have very small yeah, that was not what I was saying. When we see go to all these one well, I mean, it applies. Are we going to discuss that? Yeah, well, actually, it wasn't like 5 minutes. But what's hard? Yeah. Maybe if not today, it's gonna be something to discuss. Yeah. So you're it's pretty large. Well, yeah, that's exactly right. We felt we have something whereas we are thinking of and so that was the idea. Expanding this problem to improve the extra and the second thing is IoT is such a huge area. And discussing something about that a little bit ago. We weren't sure how right? So worried. Well, I still train.
How do we turn that and some of these other things into stories and then promote them?
Well, I think if we ask them how to do that,
Yeah.
turn it into.
Because
So it may not be somebody that might have an infection.
right.
But it's still
I was gonna say it doesn't always have to be a production story. It can be because I think that there's a whole series of stories that we want to tell, and we want to tell stuff that it's finished and consumable and valuable, and stuff that's in the pipeline. So people know that it's coming. It's like, oh, well, I want to be a part of that. How do I become a part of that? Yeah. So you think it could be a video series? And I'm not challenging. I'm trying
thinking,
to.
I'm actually, because what I'm thinking is that if we do little, maybe it's a 2-minute video on YouTube.
Or it's a series of things. But see, here's the thing, though. I think it could be a series of pieces. I think, yes, it could be a YouTube video. It could be an abstract. It could be a 3-page abstract. Here's what we're doing. A teaser. It could be anything. It doesn't have to, restrict to certain things. You've got all these channels, and they all deserve, Twitter is 40 characters of video. Visual, sight, and sound. You know what I mean? Like, let's use all of these different things.
So we could start doing that. When you get to December, 4 or 5 of them, there's tons of opportunity to play there.
But it's like, let's start, and I'm going to really need your guidance because, I'm not a deep technologist. I don't know the So you can use me as your megaphone. So if you say, here's a story I want to tell, okay, just give me the details of it. You don't have to do the wordsmith, you don't have to do the executor. Just get it to me. I can be the one that, like, if you just give me a bunch of bullet points and you want me to write an abstract, I'll do that for you, and then I'll send it back to you, and you approve it before it goes out. So if you don't want to take on that part of it, that's what I'm here for. Daniel from Deutsche. Okay. Yeah. So let's do those types of things. Like, let's begin a whole series of stories. That we, but I think that makes sense. Is talking about things that are finished and some things that are just beginning the pipeline, because that's how you get people interested in, like, oh, I know I'm going to be covering that in 6 months. I'm going to stay engaged. Okay.
We have to keep each other awake on the way to the airport. He's driving you around. I'm doing with OCP, so I'm so I'd love to work with you. If you're part, sure. Right, and I'll send you my. So what else did the story was manufactured in South Korea, tested by an American. Has to be a good product.
By an American from Lubbock.
Yeah, it has to be a good product. That's what I was saying. Germany is made and approved by American. Oh no. Where's the shopping? Excuse me? Where is the shopping? That's the headquarters. You don't sell something like special especially even if it's tables, assets, how long it takes before it's involved. When something has exactly known, it's like everything possible.
You ask them if it works. They'll say no. I'll go appoint every single specification, sign them off. They've been fully functional for 2 years, and they'll say it doesn't work.
And just about 5 years ago, I started something new way of documenting. 6 years ago when I was there, they had it, everything in front of me, and you didn't sell it. Now they're more open, figure out really oh, you have to go to rain. That's good. There's a good story there.
With what he was talking about?
Yeah. We also have a partnership with Telco. This really announced Barcelona. It's not a secret anymore. That's why we're supported, because it's easier, something easier to find out somebody else. We could exchange engineers, sending it to them. We could do the same thing with Jeremy in his lab. You guys have any
Did you guys who?
Orange. Orange Telecom.
With what now? Well, I was just saying, who was the other organization? With Orange.
With what?
The story that we were talking about.
No, so, sorry,
So which
I
story?
was confusing. So, there's, Jeremy has a lab
Right.
in California.
Right.
He has OCP hardware in there.
Right.
He's doing some prototype testing and deployment on. I think the same OCP adoption story. There's a
Right.
snippet. There's a small story there
Okay.
with Orange, which is separate from
DT.
from the Orange is DT.
DT. Okay.
Deutsche Telekom.
Daniel's the DT.
No, I know you're a DT, but who were you?
We're working together with SRE.
Yeah, but that's on a 5G thing. Okay.
I got that it was two different stories. I was just wanting to get the other firm just so I could trigger my mind.
And so did you guys get hardware?
So what we do together with Orange is we have the same pyramid, right? Buy-in. So one of the pyramid for both. We try to leverage the synergy of products. One procurement office for Orange and one for Telekom.
Yeah.
And it's called buy-in.
That's
Buy-in. We have a joint procurement. That means just larger numbers. But it's very interesting. Regulators that we don't invite so we're not allowed to know, but we can talk about it and purchase the gold and prices down. I get to the chips.
I bet you the vendors.
They did, they still do. I outsourced it. Outsourcing your procurement.
But isn't it also so they will letting the market decide? That's the right one. But that's
Problem was that they have in Germany and works like one pricing.
you know what though? That's like
They were earning a lot more. I know them. It's, they're going sometimes 50% on top of the manufacturing cost.
at the end of the day, no, I was going to say.
In the early 2000s.
Before I started, Walmart. Walmart, 15 years ago, Walmart, they will have reverse engineered the prices. They will like where you office, whether you own the building, whether you lease it, whether you lease one, your employee, whether you paid them. They would reverse engineer pricing, and you go in and say, okay, we're going to sell to you. Like, what's the price? And they'd say this. Like, no, we're going to pay this because we know what your expenses are.
I lost one of my engineers invested in Walmart. Honestly, I was. Yeah, they have their own IT network.
Oh, they have their own. Yeah, they run their own data.
I mean, they bought out one of my guys' investments as a developer. They bought him out from me.
Bentonville, and
I couldn't.
actually, Walmart.com is in California.
They wanted to pay him $200,000. I couldn't do that, and I have to pay all of them $200,000.
Was he going to Bentonville or you going to California?
I'm not sure. He didn't tell me the details.
Walmart.com is in California. Everything else.
He didn't tell me the details.
If he was going to Bentonville, that was a whole other story.
I was not
happy. It's the engineer. It's so backwards and like, you know the movie The Firm? That is Bentonville, Arkansas. The firm encourages you. The firm encourages you to have children. And it's not a big deal. Yeah, they used to reverse engineer pricing, so you'd go in and say, this is what our pricing is. They'd like, no, this is what we'll pay.
Makes sense.
Bill, I think we first heard each other when we were on you were on that call together with us in South Korea at one time.
No, I was actually representing the staff in 2 or 3 years ago.
I know your name. So.
No, remember we did a workshop over there? Okay, so that was the first time that I interviewed OCP. Yeah, I remember. I was
How small the world is.
I'm based in Paris. My company is based in Paris. We open every year.
That's good for me.
Actually, probably shortly that we had already got there. Saying yes, they.
Oh, yeah.
So, it was like,
I saw
so, yeah, so anyway.
I first used
I love doing it. I love doing it.
We're actually,
it's fun.
These guys are possibly this one is a German guy, so that's why it was very intense. He's managing the technology. But it's more important in
We're also really conservative, as you know.
And Martin has the same vision, sharing the
part of it. The Germans love trying things. They want question everything 10 times before they're sure. Basically, me and Axel got us into this. Herbert Doctor,
because we are we're working with this was 15 months ago, and then it goes to the business side of this company. Yeah,
so you're gonna have. There's no issue with that. This is what I told them. So on our side, it's fine. Everything is open. You can do whatever.
Yeah.
2 terabyte per Well, we do have it's behind us. I think this is That's true.
Hi again. It's just like a conversation. We know each other from Telco. Yeah. It's just explaining them how to use the
It's difficult.
Should be on the
Oh, so they are.
Yeah, that's a really good show.
And I've been starting something really cool now.
Tons of options. Walking before it came
By the way, when you go open up, you get the smile like that. Let's start talking together and you know what's on the
I'm easy. You want me there?
I'm talking about
Okay. Right. From that, it needs to stay some places, right?
Everybody grab a chair. So I have to look where the camera's not going to get me. Yeah, no, that's what I was also saying. And you have to like.
Hey. Sorry. Yeah, I heard you just did a great talk.
So now we have our phones and two
Nice to see you. Yeah, nice to see you.
Actually, to be fair, you should also get a chair.
All right, everybody, so I think we're going to get started again. Craig had to run to a flight, so I guess we're without him the rest of the day. I think the next, we'd scheduled 90 minutes, but I think some of this depends on you all and how much you want to discuss. But we sort of scheduled the next 90 minutes as an opportunity for the service providers to come up as sort of a panel, maybe do a little bit deeper dive into a couple of topics we've already brought up, and then let you guys ask questions, if that sounds reasonable. So I think I have some slides, but I don't think we really need those. I think we probably talk a lot about it. So maybe just as I'll give a few-minute stage setting, context kind of description, and then we can sort of have discussion and sort of makes the most sense. Does that sound good, everybody? All right. So one of the themes and one of the things that has come up today, came up during our meeting in Seoul, goes back to the management software and what do we do about that. And so from a telco perspective, I think one of the reasons we all joined this group was to make sure that we can use OCP hardware in as many places in our network as possible. Right? At the end of the day, that's what we want to do. And when you look at the activities that have happened so far, you can kind of take two approaches to that. One is to look at our infrastructure and say, hey, where are there places that OCP is not developing products and need it today? And how do we encourage specifications and encourage contributions to fill those gaps? So that's what you've seen from SKT, from AT&T, from the Radis's presentation that's going to come up later. And all that's great effort, and we want to continue that going. The second piece is there's a number of OCP specifications that have already been contributed. And so we, the telco providers, want to figure out how can we make it so that we can start using those already existing specifications and new specifications or more places in our network. And so as we've been discussing sort of internally trying to get alignment on the service provider side, two kind of themes keep coming up. One is this idea of management software, both at the server and the cluster level, and then also this idea of NEMs. And so as we've been talking, we've sort of said, okay, what do we do about this, right? How do we address these issues? Because certainly from a Verizon perspective, I have business processes and a workforce with certain skill sets that's built around management software as it exists today. And if I'm going to deploy OCP everywhere, I either need to make the OCP here fit those processes and those skill sets, or I need to change those processes and skill sets. Right? On the NEB side, we have sites where I cannot physically deploy equipment into those sites unless they're NEBS equipment or NEBS certified. So I have two choices: change the site or figure out how to get some kind of NEBS certification on this OCP hardware. And so what we've kind of been discussing, and I'll take the NEBS example because AT&T's done a great job here, is we have the situation as it is today, and we have where we'd like to get to. And so kind of, at least one of the thoughts I had was maybe on the management software and the NEBS side, we can take sort of a two-phase approach. We can say in phase one, like, I want to get the OCP hardware deployed today as quick as possible so I can get some kind of momentum going in terms of people getting comfortable with the idea of OCP. So maybe we can work together in both of those areas to figure out what can we do to make OCP look as close as my existing hardware does today. Ideally, you would improve things, and this is sort of the AT&T example, where they re-looked at the NEBS requirements and said, hey, the environment's changing, so maybe we can do things smarter and more efficiently. So then maybe phase two of our efforts start looking at, okay, where do we want to get to from a management software perspective? Where do we want to get to from a NEBS, ETSI requirements perspective? And how do we get into a more ideal place instead of just sticking with the legacy stuff? So that's where you can see on AT&T's NEBS, example where they actually did that and said, in this future world, here's how we're relooking at it. So we've been talking, among the service providers. The first thing we wanted to do was sort of make life for the vendors easier and try to get on the same page. So you weren't hearing one thing from Verizon and one thing from BT and one thing from SKT. And so that's kind of the meeting that Daniel was talking about, was let's come together and all present sort of a collective voice to you guys so that we can all more effectively move in the same direction. Right? So I think what we talked about doing is maybe under the telco work group, starting two different work streams. One on this idea of the management software, one idea that's sort of down this international version of NEBS, and figuring out, okay, what can we do there? What approach makes the most sense? We just went through a whole thing this morning. We're not a standards body, so we don't want to necessarily be coming up with a set of standards. But how can we move the ball forward sort of in a collective way from the service provider perspective? So maybe that's coming up with some guideline documents that we share with the server and storage group. Maybe that's working with the hardware management group to influence the specs they're writing. I think this is where we want to have some of the discussion for you guys, right? And some of the ideas and some of the questions. Maybe you already have all this. I think one of the things we've been discussing internally on this idea of, since you all sell to all the different countries, you already have this. Maybe this is just something that's been done and you don't need to worry about, right? So I realize that's a lot of me just blah. I had a cup of coffee, so that, you know.
I'll start it off.
But actually, before we open up to you guys, I don't know, I'll open it up to the folks up here and see if there's anything you all wanted to add.
First, we're trying to show by having the same names, 2 Daniels and 2 Toms, to show that we have the synergies already to make life easier. So trying to get them to change the name to Daniel.
You know, as a Tom, we would have to rail against the It's well, if I'll start, then you've heard me talk about NIMS a lot, so I'll forgo that this time and talk instead about management, right? Because there is a second sort of tranche here, and that is around there are many individual management silos in telcos today, right? There's typically an element manager. That's usually provided by the provider of the element, and then there's managers and OSSs, and ESSs, and so forth. It's a large stack, and it's and it varies from one area to the next, right? So one of the things that it may be the more important thing, we talk a lot about harmonized equipment and alignment with data centers, but the whole notion of operations in for telcos, I think, is also very much on a convergence path. And so ideas like booting the switch in the server in the GPON device the same way, with the same kind of image server and the same kind of process that you would use for collecting, you know, information about the optic, very attractive to an AT&T. And so a lot of the we see out of OCP isn't just the hardware and isn't just an open spec. It's a sort of harmonization of management and reapplication of the same hopefully successful methods over and over from one kind of box to another, and because they're open, we make that happen. Right? That's another very important thing that we're after.
Well, yeah, Brian, I pretty much agree with he mentioned, and just one quick remark is, I guess defining the environmental requirements is a huge task. I guess it takes a long time to actually we have a list that we can all agree on. So what I think is needed is a lot of us, community, and participants are needed to this discussion, because our requirements are different from each other. From Telco's point of view, we have our requirement. From data center, others, you know, the requirements might be different, but we need to come up with a list of requirements that could be fit among ourselves, so that we can design the hardware based on these requirements. So I ask you, active and proactive participation in this discussion and the work to be done in the future.
I'd like to also take you for there, because it's really unique to take a look at the specs that you have in America compared to Europe and Asia, that they're different. If open, or we're going to have this open compute and hardware and everything, how does it really work for us as a telco? They're different. I find it great that we all agree that we're trying to take a look at it from our specifications that we have now. What we call it, not specs, but a guide or whatever, if there's something like that, to try to come up with something that makes sense, because then it's easier and cheaper for the manufacturers to manufacture 1 or 2 cabinets or whatever, instead of 10 or 20, depending on where you're at. So I think this is the first time since I've been in the telco industry that the biggest telecoms agreed with each other. Orange also, we told him to sit up here, but he wanted to sit in the back inside. Yeah. So, but we all agreed that this is necessary, and that we need to come up with something that fits for Asia, Europe, and America, which I think will be beneficial to every vendor or supplier that we have today. In the end, it'll be cheaper for you to produce it, cheaper for us to purchase it, and we have a standard or a guideline or whatever we want to call it, and for all of us beneficial. we're not Facebook. We're not Google. Our network that we have to build, we just announced today that in Budapest, we just, let's say, lit up a data center there. It's in the newspaper. I'm sure if it's an American one, but it's in Europe. That's our first data center from our pan-European network that we're building out and we'll have up and running till Q1 2017. We will be building data centers, distributed data centers, over 13 different countries in Europe, including Germany. It's going to be a lot, but it's different. It's distributed data centers because we're working with 5G, other type of networks that we have, legacy, existing environments that we have. We are not going to build containers outside of a totally new data center. It's just not going to happen. It's too expensive in Europe, and you have to go through too many processes and approvals. We will be using the existing infrastructures. That means the power that we already have in the building, the environment, whether air conditioning or whatever we have, we'll be using existing and not changing it. It's just too expensive. We won't do it. If we say we are, that's not true. It won't happen. So we have over 30 million in real estate just in Germany, and we own 13 other telecommunications companies throughout Eastern Europe. We have to find a way to have a positive business case at the same time. It would be great if we could do it, but it's just not going to happen. Then we also have other problems. We have smaller data centers. Sometimes they're needed because in different countries you have legal lawful interception. So we cannot spread the data like America with 50 states and it's one United States. United Europe is not united. That means when I'm in Poland, I have to have at least 6 racks with servers to store, for lawful interception. And I have to have that in each and every country. So when we're distributing our network, we're coming up with an architectural design, we have to take this into consideration. So already we're coming up with things that are different than in the States. That's why we're trying to align on as much as we can, that we have some type of standards or guidelines that we can quickly buy things, distribute them in different countries, that we can take care of our legal responsibilities. And at the same time, we're preparing and working very closely together with SK Telecom, as we announced in Barcelona. We're partnering on 5G and other topics. For 5G, we really have to take a look at automotive driving, autonomous driving, and drones and all sorts of things. And we need to have the intelligence. There are small data centers in multiple locations. So we may not have a big one like a Facebook, but we definitely will have a lot of them.
So yeah, I can only strengthen that. I mean, I'm working, for example, in one of these pan-European projects, and already when we try to find a standard or a guideline to deploy something in Europe, we already ran into trouble. So it's just would make things so much easier, I think, for both sides, for vendors and for us, that we have a guideline or a common thing.
We couldn't even agree in Europe. I didn't want to add that in, but he's right. So even the companies we own, we would agree with. So it was really very interesting, and hopefully successful.
So talk about the size. That's a unit of deployment. Is it a tray? Is it a sled? Is it a rack? What would you deploy into one of these data centers or closets?
Okay,
and the real question here is understand how you deploy hardware, and you deploy rack level hardware, and then really the follow on to that is where do you see the opportunity to deploy into a 21-inch rack, or that you'll continue to use a 19-inch rack?
That's actually what the rack size we're aligning on now. Like I told you, 13 different countries in Europe, and they all have different requirements. So none of us are the same, and we're trying to force them to follow us as a mothership, to do what we agree in our group here. So we do have the ability. Our network that we're designing right now is maybe a little bit different than Verizon or AT&T. We started building up the infrastructure part of what we call TerraStream, which is an all-IP backbone. So it's native IPv6. IPv6 was mentioned here a couple of times today. And then we're building data centers, what we call front-end data centers. We're taking all the virtualized things, putting them in the front-end data center, and our back-end data centers are taking your traditional OSS or applications that come on top. So we have two things that we call data centers, and the reason we had to name them different is we had internal, say, fights with our IT department. How can you build a data center? That's our job. And we're saying we're virtualizing things. We have to put it here. If we ask you, it costs $50 million in 10 years. So we have to go faster, quicker, and cheaper. So the front-end data center is considered part of our network, so part of NT. Yeah. And the back-end data center is considered more on your IT side. We have the applications and things on top that we could avoid internal disputes. I'm trying to think of a nice way to put it. But, and
on camera, so
yeah, no. So, and now we have a new organizational structure again that's coming into effect the 1st of January, where we're putting IT and NT together. It's one organizational group now to force us to work together for the future. To be quite honest, we'll no longer be separate. January the 1st, 2017 is IT and NT, one department. This is, and we have to make it work till then. So we're going to work like a project organization and figure out how to make this for the future. So it's going to be interesting. Sit back and watch or laugh. But it will work in the end because we need it to. So, and also to the size, you said we're having basically, I think, what's in the front end, around 150 servers. Mm-hmm. I'm thinking of servers in the back end was a little bit smaller. I don't have the numbers in my head right now. So really distributed small ones, and because of lawful interception generally is approximately 6 cabinets, depending on the size of the country. If you go to Montenegro, it's only 1.6 million people living there, so obviously I have less needs than when I'm in Germany with 86 million. But it depends on the country I'm in, for the size of some of the data centers that you have to install, and it varies from, like I said, 1.6 million to 86 million. So.
And you said 6 cabinets due to lawful interception. So is storage a large component of that, or is this?
We're regulated. The regulators. It's by law.
Does each country have a different period of time that you have to store your?
Yes. Every country. Some of them are similar, but there's a lot of deviations, and we have to oblige by each and every one of them. And then we get the double whammy on top, and it gives the European regulator, and he demands something else different to the others, and then we have to juggle the local regulator and the European. So it's not that easy. There's a lot of storage.
Yeah, so in terms of, I think it's related to that question about what size would you procure equipment at rack level, cabinet level, data center level. Are you going to do now, or have you planned to go through many different vendors to find all of it, put it together? You're putting it together yourself. You expect one vendor to come with, hey, here's my entire 6 cabinet data center, mini data center for you.
Because, like I said, we've already started.
Right.
A lot of equipment is ordered. We ordered servers from multiple companies off the shelf. Cabinets from different companies also. And we hired an integrator, somebody to take the integration, and then we have for the software we hired also as an integrator. So we're doing a lot ourselves with them to try to reduce the cost. But on the beginning, we had to move fast, so we had to take a look what was on the market. We started the standard RFQ process. We went through it. Let's say took the best technical and commercial offer we could get, and then it's not the perfect solution for any end. That's why we're also a member of Working Compute, that we know we can improve this in the future. However, we can't stop innovation. We had to move fast. We had to do what we promised.
And so from a Verizon perspective, this is where I kind of go back to, we have how we do things today and then where we'd like to be. And certainly today, our business processes and our workforce skills are built around give us an end-to-end solution, we just deploy it and operate it the way you tell us. Going forward, I think we'd like to explore more business models and see if there's a way we can get more proactive in the integration piece. And especially on the software side, if you're trying to pull together different open source packages, can we play a greater role there or have greater collaboration with our vendors so that we get involved in that process instead of just being told, all right, there's your management stack, go to town. But today that's not really a conversation that most parts of Verizon can have. Certainly some parts can, but not all. And to Daniel's point, that's why we're getting involved in this community, is just to start those discussions and see what makes sense from you guys on the vendor side in terms of business case. How do we actually make this a productive thing instead of us just dictating or taking whatever it is that's come up.
That's really good. I like that because times have changed.
Yeah, I like that too. I got to follow on to that, but actually I think that question might be for all of you to answer on the granularity of, and then I wanted to come back to DevOps, but the granularity of deployment. Okay. So, or the granularity of, how you source.
Okay. So AT&T has, we're a little, not much, but a little bit further along, right? We integrated our network and IT organizations about a year ago. So we have just one road to choke.
We first wanted to see if it worked with them, and we did it.
Right? We didn't implode yet. And we have multiple sites that are of disparate size. Everything from data lakes and analytics deployments, which are more IT-centric, which follow much more closely what you would find in cloud deployment with many rows and adding them sort of a row at a time. That's sort of the deployment granularity. Everything is completely normalized and regularized, and you just connect the giant cables at the end of the rows when they come into those sites. That's but there are a few of those sites, right? Many more have been built out of expediency, where we've gone into what was a CO space of some sort, right? And have put in the extra cooling, the ability to provide AC power and raised floors so that we could put a small deployment of data center type infrastructure into those locations. And that's how we got our initial start in this space. It works, but it's an expensive deployment. It's operationally takes a long time to retrofit lots of locations, and it takes a lot of investment.
Not scalable.
It's not. But so here we are, and we're looking at ways to adapt the equipment to be able to go into small locations, into central offices. If we're using it as access, it needs to be at the edge. One of the things that's absolutely true of putting networking as a workload is that place matters, right? Think about it, an IT function is sort of a thinking function. You can think here, you can think there. And so therefore, centralizing data centers makes a lot of sense when it doesn't matter where the thinking happens. But networking is about moving bits from here to there. And therefore, here and there matter. And so centralizing networking ultimately doesn't make any kind of sense. It means you must find distributed system solutions to the problem. The gains are from being able to use common orchestration or management infrastructure from the very large to the very small, as much as you can, make it homogeneous from an operations perspective. Moreover, to the extent that we can start, managing and manipulating bits of cloud infrastructure that are distributed but act in a federated way. That's sort of the goal out there to get to. And so for the low end, what I'm saying ultimately is that we see multiple different sizes. Within AT&T at the CO level, we still have turf vendors. We still have sort of the old method of moving things into places. But you could see cabinets or racks stacks pre-populated and brought in, not all the time. Right? There's not always large, heavy-duty elevators. Sometimes there's just stairwells in a seat. And so in many cases, we'll still be racking and stacking things sort of the old-fashioned way. Doing integration, we think that to be successful in this business, you have to understand it to a very deep level, and so we tend to be active in places like open source software and open spec hardware, and to sort of drive our own destiny, if you will.
Do you combine the movable and fixed networking infrastructure in the that company now? Or?
Yes. So we didn't. At one, obviously, we're a company that was what would you call it? An accretion ball, right? Lots of different telcos brought back together over time, including mobile providers. But very much AT&T is an integrated provider, so we see a lot of overlap in providing next-gen fiber networking from what would have been called wireline. It's a necessary component of next-generation wireless, right, with a much denser type of footprint for 5G, for example. So these things work, they dovetail really well. We do very much see next-gen networks as sort of combined, from our perspective, converged.
The same for DD, absolutely.
To the core architecture plan, indeed, that's the mainly for this side of the region.
So the question was around CORD, and you should know, first of all, that CORD is a reference implementation, right? So AT&T isn't going to go and, well, not at this point, have we sort of open sourced everything we do end to end, right? So we needed to come up with a thing we could point at and say, this works how we like to see things work. And while AT&T has our own deployments and infrastructure, they're not all OCP spec, they're not all open source yet, but the CORD reference implementation was sort of, we wanted to put something out there that was very much a directional vision. Everything is open that we could possibly make open. And a common infrastructure, what I would have called NFV infrastructure, is underlying both mobile and fixed and enterprise as three different applications, the R-Cord, the M-Cord, and the E-Cord. And indeed, you also put your analytics collection on the same infrastructure. So it's very much converged hardware and supports all the different kinds of applications that the carrier would have and that third parties might want to come and place in carrier infrastructure.
So I think Jeremy came up here right after that first question about the role, so I don't want to lose that fact since you drew your chair here. So
yeah, I wanted to stop hiding. I think I wanted just to come back about the point about manageability. Somebody talked about management tools that come from integrated solutions at some point. And that, so my role is in the lab at Telco, and I basically do the new technologies constantly. And I've seen firsthand that if you have the controlled infrastructure, you cannot integrate anything. It takes forever, or it's never going to happen. And in our lab in San Francisco, we've been running open source since the beginning, for the past 6 years or so, in that stack. And that simplifies the life immensely. Obviously, if you need way more people inside Orange to be able to handle this in production, people that are hands-on, or that have understanding of the full stack or a lot of pieces of the stack, and they know how to collaborate with the other teams. It's a huge transformation, as you pointed, inside the company. It's massive inside Orange, but it's happening inside Orange. And but it's a requirement to be able to integrate new technologies, move faster, move from our old, really legacy systems that we deploy and we don't look at them for 10 years, and then we stop with the new technology for 10 years. I don't know how 5G is really designed, but I hear it's kind of disrupting the way we do core networks as well, and it's going to change how the 5G is going to integrate with the applications, most likely at the very top of the day. It's not going to happen if we're not agile. If we rely on a few vendors that offer standards that are ratified every 5 years. It's just my observation being in the heart of the Silicon Valley, where when a vendor that is, even startups are trying to have you locked in since the beginning, you try that. You tell them, no, this is what you have to play, everything is open source from top to bottom, and all the issues that you're having, you have to open source them, because I have to see how it's done. Otherwise, the next vendor I'm going to see next week will not be able to do the same way of the market. Just wanted to give my R&D perspective.
So I see a common set of challenges and goals, and no common requirements for management or environment.
But I think that's why we're here, right?
Yeah.
Is we want to the best we can, come up with a common set of requirements, right? Working with you all to do that. That may be an ambitious goal. I mean, there's probably a reason why we don't have a common set today, but I think, at least from a Verizon perspective, that's one of the reasons we're here, is to see if we can push things closer in that direction.
You could start with NEBs and take things out that you think you can soften up. Do you need 55 degrees C for 96 hours? Maybe not. So you could redline that out of the spec. And so you could come up with a softened NEB spec.
We're also first taking a look at all of our different specs that we have today,
yeah,
and just trying to overlap them to see where do we have already synergies.
Yeah.
That's a no-brainer then. That's the easy one, and where can we make them? And I think this is the first time that we've ever tried that, all of us, the big ones here, that really to take a look at our specs that we have and to really overlap them to see where, and we're already sharing this information with each other. Before we really hit you guys and talk to you, we have to know where we are. So that was one of the reasons we had that meeting, and we had the line to see which information, let's share it. We're talking open here to see where do we have things that are overlapping, no-brainer, and where are things that are Europe, Asia, or America that are different. Can we change them? Can we not? Can we some way bring them closer to each other? And that's what we're really working on now, like Brian just said. And once we have a better view on that, we'll take your influence right now, don't worry. We'll provide you with our view on that as quickly as possible, what we think. That's what we're working on right now. And hopefully,
on my input, you're going to get data center no NEBs. Well, data centers have safety and manageability and availability requirements as well. And if you take the titles off of the specs and you start walking through, you'll find that a lot of the concerns are in the same direction. It's not like Telco people think it's completely different from. And it's really just some of the. You might think so. I'm sorry. So, but it's I think it's a case of degree, right, and not of type. And so, given that we understand the set of types, understanding the brackets to put around the degree for reasonable market access, I think is a reasonable thing to do. So like a 35 degree C maximum ambient is going to be an awful lot easier for this group to manufacture to than 55 degrees C. Mm-hmm. So, but that's your choice, not really our choice. We absolutely. We'd much rather have 35 degrees C.
So I mean, the question to the audience on this topic. So Daniel just mentioned we're going to try to do this sort of puzzle game and see where the overlaps are. We already done that. I mean, certainly we don't want to redo work.
We already done it. We've been doing it for 20 years. Okay, as an equipment vendor, artisan, Motorola computer, Force computers, what we do is we lay together the specifications for NEBs, for enterprise, for medical, for railway, for nuclear, for industrial, and 80% of it's the same. So we build our own internal spec on how we build gear, how we test gear, how we create product, and then as it gets closer to the final, you have to, aim it towards a particular, industry, whether it's telco, whether it's railway, whether it's military. Okay, but underneath, a lot of the principles are very similar. The four corners testing, the reliability, the safety, all that similar.
I'd advise you to throw it over the wall to a consultant, have them do it, because you're going to be inside your own silo trying to get out. There are people that have already been outside doing this so that we can build electronic gear that satisfies multiple markets. Okay? And there's some cases where it absolutely flat out won't work. You know, there's some medical stuff that's just completely crazy, and there's some military stuff that's absolutely insane. Okay? But 80% of it is similar. You know, the temperature shelf.
Telco supports the military. So.
Right. I mean, honestly, I've been in these conversations with these customers, and they bring up a requirement, and first thought is like, what? And then they explain it, and I'm like, oh yeah, that makes sense. You know? So I think that it would be quick to, I know a few of these guys at our company that have left that have put together these specifications that's it's an overview spec that would meet most of these requirements. And that would be really helpful for you to use that as sort of a baseline in the reliability area, in the you know, the temperature, you know, how long something has to live. It's been done. But yeah, I'd say work together and do it, and it would be really valuable.
So maybe now I'm going to bring back to DevOps a little bit. So
before we go to your question, I'd like to hit that one back over the net. It sounds like your company has a tremendous opportunity to give very valuable contributions to those.
Yeah, we're debating when, where, how to jump in.
I'll say you have our email addresses where you can share your information.
If you need someone to help you cajole your management,
okay. I'll tee it up. Yeah, it will be a recommended sort of broad-based standardization of what could be useful.
Yeah, just so there's a baseline where we can start.
Yeah, baseline, absolutely.
I think if all of us would jump in and talk to your management, they would say yes. It would be very interesting.
Okay, let's see what we can do.
Are you going to circle back with him?
And Tom, you take the lead and you control everything.
Owners and stakeholders.
That's what it's all about.
Right. Owner.
Hello.
So what I was going to ask is kind of, I think it relates to this, is there's a lot of discussion about sort of normalizing and then putting out something, which is what speed can that happen, and how open are you guys and your companies to iterating the process? I get that because this forum and what's happened here over the last couple of years has been incredibly iterative and DevOps in nature. And for that to work, it's not just how it's done, but the customer has to be there too, right? Mm-hmm. So something goes, they may not be done fine. But you go out and more than just like one in a lab, actually deploy it, right? And then you find your way. That's a little different. That's not how telecom networks have been built or operated, right? You tend to want to get it pretty perfect before you do anything. So what's your approach?
So, I mean, I'll just talk from a Verizon perspective, right? So certainly Verizon's a big company, and you know that just brings a whole set of challenges with it, right? But I feel like as a company, we've made the commitment to participate in this group, and we did that for a reason. It's to get in more of that mindset and learn how we can do things better. So if we're working together and we find out that, hey, we really need perspective on how to iterate this to get the lessons learned so you can actually deploy whatever it may be, I think that's why we're here, is to get that information and take it back and figure out how we can work internally. So I'm not saying it's going to be like smooth sailing right off the bat, but the reason we're here is to have these conversations and how we can figure out how to do things better, both with the external engagement and the internal processes as well.
I would follow up on that. I think that the kind of equipment that's getting deployed and the way that people are deploying it is changing. That if you look at classic telco deployments, they were planned to be in service for many years. And what we find now is that a lot of the data center deployments actually can make good business cases for replacing servers every several years just based on power savings. Okay? So we expect this to become much more,
Well, we've gone from 5 nines to accepting failure from equipment.
Yes,
Or moving where it
and that
happens.
too, absolutely. And maybe not replacing the failed equipment until it's time for that whole pod to get changed out. So that means that there are, and we're working on operational changes and DevOps and how to apply that to a telco. And of course, there's a lot of mind bending that's going to have to happen for that to get worked out. But it's clearly a path and one that we want to follow. And I think that the upshot is that there will be more frequent change out or update or what have you of equipment and software than there had been before. And so it does give opportunity for moving in new OCP spec hardware and new open source software over time.
So any other questions, comments?
I'll make the same comment on management and on environment, that I'd be exceedingly surprised if you had much in common at all with how you manage your products. You know, tools, protocols, anything like that.
That's a case where we're much more amenable to taking on management practices that are commonly found by cloud providers. I think that they're being homogenized because the marketplace for cloud services is the customers are demanding more common interfaces from their cloud infrastructure. And as that market solidifies and becomes more, consolidated, what you'll find is management paradigm emerging. And so ultimately, I think most of us are going to wind up figuring out how to take the lower end of physical and infrastructure management and map it to what we have now at the top, which was our BSS facility that sits on top. And so we won't be all identical at the end of the day. We'll different with one another based on the service layer, but going down into the deep waters, you should find, with any luck, the same kind of infrastructure management, the same kind of
when we take a look at the legacy, we all have our element managers from suppliers, and the hardware is at least the same. Yeah. When we do the umbrella, I know that we're all a little bit different, but it's
so where's the connection between what this group can supply and what you need?
Yeah, I mean, just to emphasize Tom's point, right? We get asked all the time, why can't we operate like we do on Facebook, right? So I think we're all getting driven in the same direction. We may be starting from different places, but we can't just snap our fingers and do what Facebook and Google are doing. We need to, help doing that, and hopefully, as we're on that transition path, moving to the same point, we can get more.
You need a connection into the rack that's going to let you just touch everything that's inside of the rack. So Ethernet. Okay, we started this back. But what protocol can you handle? You've all done adaptations, you've all done experiments, so are you using SNMP or RMCP or something else?
NetConf.
Sorry?
NetConf.
That's actually something that I know AT&T and Deutsche Telekom are using NetConf Young for the modeling, and that we're demanding that in every RFQ, either you're NetCom Young compliant. It's been standardized for over 15 years, and if you're not, we're not going to buy it. As a way to have the interface that we come in the cabinet. And at least AT&T and DT have started that, and when it comes to RFQs for 300-400 million, then you'll see how a lot of companies suddenly start changing and adapting. And we're not standardizing something new. NetCom and Young have been around, honestly standardized for over 15 years, but just over the last 2 years or so, I think, AT&T and DT have been pushing it now and demanding it in every RFQ that you have to be compliant. If you're not, you're out. Very simple. And if we'd be glad to have Verizon and everybody else join it. Orange is also doing that sometimes now. I saw your last RFQ. Yeah. They're pushing NetCom Young.
Because you don't know we buy stuff together. That's why they know.
Yeah, I forgot to. We have some joint things that we do. But we're demanding it in a lot of different areas, and this really, it exists. The standard exists. We're not doing anything. We're just utilizing what exists on the market and trying to force the people to deliver it.
As your management guy over there, what he needs to write.
And
Well,
really,
it's not to say that ONI or SAI are bad interfaces, and I think there are many more management layers than just NetCom. I know that the whole idea behind NetCom was really to force that into what we call legacy network elements, so we could tear them apart from the EMSs that we're using in them. So I don't know that that's as necessary in this environment, but we've built up a large infrastructure that's able to take the end models and compile configuration and create and configuration. It's managed that way.
we call it by us, utilizing it also real-time NSM. It's new, what we're trying to do with fully automation, and we're developing a lot of things ourselves, like always, but using that NetCom and Young and trying to get away from all those element managers and all the other things that are in between there that we don't think are necessary for the future.
So on this topic, I sort of have two hats, right? So from a Verizon perspective, I would say, expect to see some discussion on the email list during the monthly meetings, sort of a work group stream. The service providers figuring out, okay, how can we, get as close to on the same page as possible, working with you all to say, okay, what makes sense? How do we drive this in a productive direction? With the OCP co-chair hat on, my question to the group is going to be, if you have thoughts now, great. If not, think about it. Is how do we then advance this inside of OCP? Is this writing some kind of guideline document from the telco group and sharing that with the management group? Is it direct liaise with the management group to get that moving in the direction? I think we need to figure out, that was kind of the whole discussion this morning, right, is how do we push this inside of OCP? So I think that's going to be sort of a, something that the group leadership, however you want to say it, is going to try to figure out how to address, in addition to the service provider specific stuff that I care about.
This is the first sign of consensus that I've seen today. That's
Positive.
good.
Positive.
And I see 5 tier 1s sitting up here all getting together and coming up with common specification. Would you consider reaching out to other service providers that, to let them know what you guys are starting to maybe build more velocity or more momentum behind this? I don't see anybody from here or China here or Latin America. There are a couple of other tier 1s in the U.S. that I would definitely like to see on board with this. Well, I'm just saying that this could grow. This could get even bigger.
I think NTT is debating to OCP. Debating for some time. Yes, I want to talk to all of you. NTT.
Yeah, we talked to them as well.
So NTT was by us also discussing with us, and we shared some information, what we're doing, also with the NetCom Young and other things for the management, and also what we're doing in the group. So I think if NTT would join, if you could, yeah. But I think you have some of the most powerful telcos already here. Take a look at AT&T, Verizon, Deutsche Telekom are the strongest in Europe. In Asia, you have South Korean Telecom, Orange covering half of Africa or more. I mean, we don't have the strength to change it. In standardization, we used to say if you have 2 big telcos and at least 3 vendors backing something, you'll get it through. Have your 5. Yeah. Since when have we ever had 5 sitting down together?
No, that's exactly what I'm saying. Is, I think reaching out or publicly announcing that you're a large gravitational force now. That the 5 of you together.
That's why NTT is already talking to all of us. They see what we're doing and they're all getting curious. Even the smaller ones. Turk Telecom called me. Here, what's going on there? Can you give us more? I mean, the smaller ones throughout Europe are also getting interested and already getting in touch with us because they're saying, what are these guys doing?
And NTT was very, very present on the workshop of OCP in Austin, for example, and reached out to us. We had discussions there. It's just today we figured out that we are suffering from different problems still, organizational-wise. So for big companies like Telco, it takes a while to get into this.
You can't change this overnight. However, I think we're going the right way. You said the first time you heard consensus. I mean, I really, honestly, I think we're going the right direction, and that we have to go this way. And I think everybody knows that it's just kickstarting some old traditional companies, the old Montbell, like one said, like that, but AT&T was then coming back together. Deutsche Telekom, I think companies that are really tough to change processes and stuff, just to get them to say, we're joining this OCP. We see advantages there. I mean, it's something that didn't happen in the past.
I think we saw the near term as all 5 of us are here, we're wanting to do it. Let's seize that opportunity to build some momentum, get the ball moving, and then hopefully as we do that, we can start attracting the other tier 1s and other service providers. But since we had sort of a critical mass here, it was like, let's just start.
I think we can drive it really good, yeah.
I would just enjoy it.
The main players.
You could move, yeah, I mean, agility, right, is part of what this is about. You didn't weigh yourself down with 15 back to kind of
standard.
Right.
Yeah.
Can you imagine
It's
aligning with
already-
15?
You're already, yeah.
It's not easy, it's interesting. So, yeah, but think about it really when it'd be more. I think when we can align on a lot of things and then bring them in slowly and they jump on the boat with us, I think it would be much easier than really having 10 to 15. That would be very interesting. I'm not sure how the discussion would end. But.
I mean, it's balanced, right? We don't want to exclude anybody for sure, but we want to make sure that this doesn't turn into a standards process that takes 5 years.
5 years, and we still don't agree in the end or something.
And we already have homework, so we should not run around and first we should work for something.
And we need to complete what we started.
Well, if we can come up with some kind of common set of requirements for the management, it makes your deployments a whole lot easier because you've got some expectation that you can plug it in and talk to it.
I mean, we're all for keeping it simple. We know what complicated it is. Just take a look at our legacy network. So complexity, we all know it sitting here. Let's keep it simple. I think we're all on the same path.
I think in many ways the networks we're building toward are much more focused on how can you have a lights out environment, at least in some cases. We're interested in small sites, cell sites even, where we can deploy this type of equipment. There won't be staff, right? So that's going to be much more important than the way we used to think about having equipment deployed with techs on site and managers for the techs and whatnot.
Like Tom mentioned earlier, with the management, with the servers when they're defective, when we started our discussions internally with our network operation guys, and they gave us the requirements, and we tried to tell them that's history. We're looking in the future. That doesn't apply anymore. Just to change this mindset from them, that they realize we don't have to have 24/7 by 4 hours to repair. I mean, just to get them to change that with SLA thinking. When we did the new RFQs for our data center in Budapest, we had problems getting them to change the mindset internally in the telecom to make them realize we do not have to demand that 24/7 by 4. We have, I mentioned it in the architecture, the server can be a month or longer defective. We have no problem. It saves a lot of money when you can do it that way. But this mindset change is not easy in old traditional telcos.
Getting them, your internal people, to accept the idea that something's going to break and it's okay.
Yeah, and that's a big deal. Yeah, but then they start screaming, yeah, but we're operations, it's our responsibility, and they have, we're slowly, I think all of us, learning together, and also with our operations people, that we're going to this step function, going to this new world, and we have to do it together and learn together on it. And it's a slow process. So a lot of people that don't believe us in operations.
Okay, so any other questions from the group? I think just to wrap up then, so what I heard was Tom and Artisan are going to see what we can do in terms of this consolidated international NEBs. I think on the management software piece, I'll take the action to work with the hardware management group to see what makes the most sense from an OCP perspective. And then I think on the service provider side, we still have some additional coordination to figure out, how we can do that. So expect to see some emails on the mailing list. Certainly once myself and the hardware management group coordinate, we'll share something. If you all have ideas, I can't emphasize enough, please use that mailing list. Recommendations, use the mailing list, and we'll kind of go from there. So with that.
And we need
Anything
more
else on
women
the panel?
to come out here. I mean, we have a quota in Germany that we have to have at least 30%,
Most of them work in marketing.
Yeah, but we invite them also to make it just optically look like.
Some of us.
We did have. You guys have to work on that.
Yeah. Thinking we're gender thing. You can't say that anymore.
Yeah, that's right. Yes. People change their name from Daniel to Daniela and stuff.
I think we had one at the last the Austin meeting.
Yeah,
Suzanne.
Yes. I mean, because really, we're pushing. I have to tell you anyway. At the University of Leipzig, we actually own it, Telecom, and our HR boss was in there, and I was with him, and he was giving a speech, and he was talking about how we want more women, and he's like, we're going to get it on, and the women that are here in the audience, you have a real chance, and suddenly we hear in the audience a lady's voice go, yoo-hoo. And then he's looking like this, he's like, stand up, stand up. Why are you saying yoo-hoo? She said, I'm the only woman here that I have a guaranteed job. So we're talking university, it was only in engineering, one young lady there. So kind of funny. And for our working, trying to deal with the hardware specs and stuff, I find it really interesting what we're doing already, and looking forward to see the results.
Absolutely. All right, anybody on the panel? Anything else? Closing?
He just texted me and he's sorry for not being able to attend here.
Tell me when he meets me in Germany, dinner's on him.
He goes around for that.
Yeah, they were there a while back, so dinner's on him the next time. I promise not to invite 20 people this time. Good.
All right, well, thanks, everybody.
Thank you.
I think we'll now, we're actually ahead of schedule, so that's good. So I think next up we have Radisys. So maybe give us a couple minutes to rearrange chairs. You guys can come up.
Maybe you heard that. Telecoms are ahead of schedule. keep that, please. In the back of your
Set the bar. Uh-oh. Where was that?
Get away from it.
Are we taking 5 minutes or just?
Come on up. I say let's power through it.
We have an hour left.
Yeah.
We were gonna, I think we need to coordinate this with.
Just we have to go to the airport, power through.
Make an announcement that we're gonna start this at 4:15.
Oh.
Line them over to one person in.
I
Okay.
was not aware of that.
Let me go
So
check
do you
and
want
see
to?
what that's at.
Do you really want him to have another coffee? I don't know.
But I can only say that me and Daniel from SK Telecom have to leave at 5 because we have a flight.
You better leave on time.
So we have to leave at 5, not that we miss our plane. Glad you joined.
Are you going to stay there? Or you want to come back? That's Radisys. Andrew, are you guys going to have slides?
Yeah.
Okay. Just making sure we have the right. They're doing Google Hangouts. I'm making sure we have the right.
Do I have to? I didn't set them anywhere, but
Will you send them to me?
I will. I didn't have it yet. Yeah, I sent you this back. I don't think I sent you any.
Yeah, I sent you this morning. After you put the.
Sorry.
No, sorry.
slides or something.
I put them up on, but I don't remember sending it. Let me know if you got an email from me because
Okay.
I don't remember. I should have. I can send it right now.
No, but the other.
Yeah, in case I can't find you, you can find me.
I don't think I'm.
Okay. Too much is going on. That's okay.
I'll look. I mean, do you want me to? Yeah. I got it. So, do you want me to send it right now? Is there a, if you make it out here?
On the wiki.
Right.
No, I have to go on the PDF.
I got it here, but I swear I didn't send it to you.
I'll convert it, but it'll.
No, I got it. Because it says bumper.
Right.
But once I PDF it, it got a little. Yeah, 10 minutes, guys.
Sounds like that sounds good.
Good questions. Standards are 35. Sometimes you need somebody to point out the elephant in the room.
Best analogy that I've heard so far is it's like herding cats.
Yeah. It's about right, but my experience pretty focused, collaborative cats, which is even better. It's better than I even expected. The transparency was refreshing. Pardon me? I have a 5:45 in the morning flight. So I'm heading to the airport around 2 in the morning. I need to get it out of Boston. Like 10 minutes away, yeah, in town. Well, no, because I'll get there. I gotta drop off the car. So I'll get there at 3:30 for a 5:30, 5:45 flight. They said that there can be traffic at that time. That people start pretty early. How about you?
I think tonight. I was thinking of doing tomorrow.
Yeah.
Just drive along.
Where are you?
Rhode Island.
How far is that?
130 miles.
3 hours, 2 or 3 hours, 2 or 3 hours, depending on the time of day.
I always still start at 10 o'clock tomorrow.
Yeah, nice. It'll be nice and fast at that point.
Yeah, still have construction on whichever way I go. Yeah.
Which one do you take though? Do you go to Boston?
I came through Boston on the way up, and that was a mistake.
Yeah.
I'll go 28 or 495 on the way home, and both of those will be a mistake.
Yeah.
Enjoy the ride.
Yeah. I think if I go north and then go through Vermont and then down around by Albany and then come back in on our way.
So triple the miles,
Yeah.
but half the time.
Right.
Do the math on that.
Yeah.
Oh, we have that in Raleigh.
Right.
Coming from our city, you can hit north and get there quicker if you take a longer route on the 540. Really? That's over 40 around. It's really short. Yeah. But the shorter route has a lot more lights, lower speed limits.
Yeah. See, I'd rather drive farther and be moving. I want to feel like I'm making a car.
I got a standard transmission in my car, so driving and stopping and go is painful.
Exactly. What do you drive?
Maybe BMW.
Z3?
A baby. 128.
Okay. You like it?
I like it a lot.
Well, they just came out with the 128 like a couple of years ago, right?
Came out in 2008.
Oh, that long ago?
2009 for the US. I picked it up in Munich.
You love it? Did you do the flyover and drive around from there? My father-in-law and my mother-in-law are doing that with the new Volvo XC90.
Wow,
Which that is a monster of a car. Have you seen the new ones?
Yeah, they're huge. It's like
They're huge, but the technology,
amazing. You can fall asleep and you'll be safe.
the technology. Well, you know, we have an Xfinity QX60, and it's got all of those things where if you have all the sensors on and everything, it will stop the car if something gets in front of me without me touching the brake. And it's happened before.
It's amazing. Tesla S.
Yeah,
Self-driving,
right.
leading the way.
And if I change lanes without putting on the blinker, it'll tap the brakes on the outside wheel. But it's unbelievable.
Yeah.
And my wife always, when I get in the car, she turns on all the sensors. It's like really making me, and I'm all off as soon as she's not looking. Like, no, I'm driving.
Driving on the Autobahn with my new toy was fun. Really fun.
I bet. But that new Volvo is unbelievable. You should go to the dealership.
It's like little things with big engines.
Yeah.
Things with big engines.
This is a big thing with a big engine.
Yeah.
No thanks.
But it's unbelievable. But they're $90,000 now.
Yes.
Which is crazy.
Also got a 44-year-old BMW.
Do you really?
Okay.
Yeah. Nice.
That's good.
Keep it pretty good. Nice.
You can put your hand through the front fenders and through the firewall and touch the fuses under the dash.
Oh wow. How much did you get it for then?
$5 grand.
And what's it worth now? How much? 35 or 40? Nice. Right.
I did a little bit of work on it.
Yeah, I'm sure you've invested some money over the years.
Mostly labor.
How often do you drive it?
Very. I went to a car meet Saturday and it put 18,000 miles on it in 30 years.
That's funny. That's funny. Driving into church and back.
Yeah, that's about it.
That's awesome.
When I go get an annual inspection sticker, the guys laugh at me. Hey, you drove 400 miles this year.
You change the oil yourself, I assume.
Oh yeah, well, you know, did all the body work myself.
Oh wow.
Rebuilt the engine myself.
Oh wow. That's fun. Pretty simple back then.
Front fenders are welded on.
So I'm talking about the engine. Compared to what they are today.
It's German, so.
Metric system. And
That's no problem.
No, I'm teasing.
Tolerances and stuff. And
Yeah.
special things. Parts are expensive. Now that it's
how's your I-28 or what is it, the I-128? How is that to maintain?
it's actually been the most reliable private BMWs for more than 30 years.
Because I haven't owned a BMW and I bought an M5 a couple of years ago. Well, I was going to say, and I was miserable. And I sold it after a year and a half.
If you plan on an M5, V8 or V10, that's better. $2,500 in maintenance a year.
No, every time I walked into the dealership, it was $2,500.
All right.
For whatever, like they found stuff all the time for breaking all the time. So
I think we're going to get started.
I was pissed off because I had a warranty, an aftermarket warranty. But once I hit 100,000 miles, I was like, done, see ya. And we had a Mercedes, we did the same thing. It's done.
The 7 Series, after it's 4 years old, was worthless.
Yeah.
Because nobody could fix it. So it's the car mechanics that are driving 5-year-old 7 Series.
Wow. So that's funny you said that. That's exactly right.
So,
They're buying. Okay.
Andrew, you may have to type on the console there to tell it what input you're using.
oh, thank you.
There you go.
Thank you. All right. Now, shall we go, Bill? Are we waiting on someone? Or
No, I think we're it.
okay.
Somebody went outside to go around. Ryan.
Oh, okay. Oh,
Round up
right.
a few people, I think.
Okay. Ring the bell. That's what he's doing. He probably should. Get ready. Okay. All right. And this is the last thing on the agenda?
You're the only thing standing between us and
Or happy
hour.
and beers. Yeah. Take it.
Not necessarily in that order.
Okay, so so this is kind of a continuation. Actually, maybe just a quick. Who was in Austin when we first kind of talked about this? Some of you. So we'll do a little bit of a refresh. But we're moving ahead with contribution and getting the spec out for what we discussed. And we've come up with a name here too. So this is kind of you know, a review meeting. At the same time, I don't think we quite have the form, or that we're not going to go line by line through. We did get the spec out on the mailing list, and it's posted. So we have gotten offline some comments. So what we will do is take whatever we get verbally, whatever we get through whatever channels, and we'll echo it all back and say, look, here's what we got. You know, here's it on the tape. So we'll keep the pen.
You're going to do that on the mailing list, right?
Yes, on the mailing list, yes. But we'll keep it. I mean, we're fine either way. If people want to just chime in the mailing list, that's great, or we can consolidate and echo back, so we'll do a little bit of both. So I'm Andrew. This is Matt. I wasn't in Austin. I think Matt was, and at least one of the women there was our Suzanne, who gave her presentation. We should have brought her back here. Didn't realize she wanted to represent. We're both out of our CTO office. The Matt is the author actually of the spec. His name's on there, but you know, in collaboration, and it's out of my team. So what we've got here on the slides is a little bit of a kind of what we're doing, kind of a quick recap of a couple things, and then I grab sort of the contents and some pictures and things to just take a snapshot of the spec itself. So what are we doing? It's been interesting, and I think it's a good point in the day to have this because a lot of the stuff that's been talked about, you know, we think this is in play. We think this is a good fit for a lot of the things that we've talked about. It's probably not the final and only thing. I think there are many dimensions of you know, infrastructure and even open compute in carrier networks. But this is something we've been working on for a while. It's been collaborative with other vendors as well as with our customers. We started this with the intention of being part of open compute, but it went very quickly. So the good news is, and as you heard this morning in I think Bill's presentation, I think it fits very nicely with when you contribute something. You also want to say that you have it, you can order it, you can buy it, and oh, by the way, it's going to evolve. And I think it fits that. So we're actually contributing, and it took us a while to kind of figure this out. But here's what we think we're doing, and I think this fits perfectly with what Bill outlined this morning. We're contributing the spec that is basically defining sort of a standard or an interoperability requirements for this rack level instance of OpenRack. It's a derivation of OpenRack. And then we also have a product instance of it, and there will be others in the marketplace very quickly, variations. And so we can also put those. We haven't decided. The sequencing is first focused on the spec, and the spec has nothing greatest as particular in it other than we're writing it. And our product will meet it. That would be the thing. Okay. So our names. So we're calling this carrier grade OpenRack. We originally called it Telco OCP. We've gone through a couple of names. We thought this is kind of aligning with it really does relate to OpenRack. We put carrier grade to kind of bring it into this forum without calling it Telco. So there's some things we thought about. What is it that we tweaked and tuned? It fit most with kind of a little bit more of a service provider type of environment. So that's what we're talking about. Our own commercial product, we call it DC Engine. So that is done, stuck, and so that's our name, whether you like it or not. But that's an instance of the product. And some of the pictures that we'll show would be from what we've actually built. And so we've got collateral, spec itself, and then we've got things around that product. So I think, again, we need to be careful to kind of decouple them. There's a spec, and then there's a product that we built. For that, we have some installation guides, manuals, SKUs, and some other marketing material. Okay. So a couple slides that we presented in Austin, I just brought it back here, and I thought I'd kind of flash them up because I only saw less than half the hands go. We came at this. This started with how do you make open rack, open compute technology, bring it into telco environments. Certainly, you bring it in as is, no changes. I mean, people have done that and looked at that. But there was a thought of, maybe you could, really sort of tune this for this environment. So that's where it started. So I called it the base model. The other thing I think is important, and even listening to what's going on in rack right now, we intend to track. I use that word kind of loosely. It's not a tight coupling, right? This is a splinter. It is a derivation. But when things happen, this is not intended to be some random, wild, different technology that's just come in here in this place and put it. We really did intend to leverage and track from Open Rack and all the goodness there with some changes. So, for example, if 48 volt is, wow, we got to go there, then we'll bring it in. And by the way, architecturally, there's nothing that blocks that, but as you heard this morning, there's stuff to work out. So that's what I mean by track. That's the intention of kind of having it in the same form, in the same collaboration. One of the ways that we brought our own experience, Artisan mentioned, I mean, we've been in this space, we understand this space, we've worked with Thames, Nokia and the like, and with a long-standing relationship, and we work with operators, and so we have that blend. But in this also, we're listening. We see ourselves primarily as someone who's listening, trying to stitch this together. So we're really not trying to come and say, here's some Radis's thing, we're trying to kind of serve a need that we saw there. We're really not concerned about backwards compatibility. So this is all pretty new and go quickly. You heard my question about kind of DevOps and agility. We practice that here, and I think it's a good process, which also means this can evolve, right? I don't see it being all that locked down. These were, again, we had these in Austin. This is kind of what you're going to kind of see packaged into the spec. But in a way, the spec is we try to go very minimalist. You spec too many things, and then it's going to be, it just gets harder, right? The more people in the room, the harder it is to agree. So these were some of the things that drove us. So we talked about the different environments. It's not necessarily greenfield data centers. You've got smaller COs. You've got weight limitations, size limitations. You do have NEBs and other environmental requirements, so we want to deal with that. Fundamentally, the size was something right off the bat, and I know there's different options, inside of OCP even now, but getting to a 19-inch, kind of standard rack, seemed like a need, and again, it is. And then also the depth is something we looked at, something that was friendly for that environment, but there's some variability there. I think this was mentioned this morning, so I didn't create this slide today, I didn't make any adjustment, but heterogeneous compute loads, certainly being able to get volume, step and repeat, big hyperscale deployments, but also room for some kind of accelerators and some heterogeneous technology. What else? Management. We have a lot of thoughts on management, and we've done, as a company, we've done a lot of things, but we're not putting it on the table here right now because it's complicated, so we want to decouple. So what you're going to see is a very minimalistic management approach, and some of that comes from our own history of what each customer wants and how variable it is. So when you want to try to get a common denominator, we thought go small, and then all the things we could do.
And so we just included the part essentially that allows them to be managed.
Yeah. So in the spec itself, what you're going to see is, again, keeping it pretty bare bones. There's a lot that can be layered on there, and I think that could be additional contributions and specs that could come out of, and I'd love to hear it coming out of what we heard on the panel to drive direction. So I think that's open right now for more shaping. Let's see. I did mention NEBs was mentioned here, and that's a proxy. I know the whole world isn't, NEBs, but there's NEBs-like things. We said optional. We spec anything about, you have to meet this, but it's absolutely, there's things that we did do that make it reduce it to NEVs. And then you know, individual vendors, you can see what their NEV solution is, but it's been thought of. We might as well mention the power since you know, it is the 12-volt power bus. You know, it looks like open rack. Again, maybe that evolves, but it's starting in the same place, and uses actually the same connectors and so forth. Okay. Kind of conceptual picture. So it is narrower, you know, than open rack, and it's two, you know, sort of half width and full width modules. So that's kind of granularity. I might as well mention it because it was mentioned this morning. You know, if you've seen the LinkedIn Open 19, there are, you know, if you just squint and look, there are some similarities in terms of kind of the shape of things. You know, I don't know what to make of that exactly. This was not done in collaboration. This doesn't have any connection there, but we think this is something that can be sort of a variation that addresses that need, you know, inside Open Compute. Let's see. Anything else we're going to say about this? This is just kind of a way that it could be laid out.
You'll see later on that the pictures on the right show that our sleds are set up as 2U high. And part of the reason for that was to be able to use the 80mm fans, which somewhat was there to reduce noise, basically. So there's, in a sense, a clumping. Our sleds are set up to each of the functions to take one U, and so there's basically two functions in most sleds. I just wanted to let you know that we have that height, and the height partly is related to the fans. That's why you're seeing that.
Which drives back to environmental acoustic, you know, things. So that was thought about that, and then there are actual U's. You know, so again, one thing we thought about in the early was kind of snapping this to grid, right? 19 inches, 1 U2 standard distances. So you get some leverage out of that. Okay. I'm going to go quickly. There's a lot of words in these. This was just kind of flashing up, but again, it was actually nice to see it this morning. In Bill's presentation, he mentioned, you know, for something kind of new to come in, there's 4 principles you ask. You know, does it adhere to those principles? And they were fairly easy to answer because we thought about them from the beginning. So I'm not going to go through all the words because I think we'll probably take too long there. But you know, what is it? Efficiency, scale, openness, and impact. You know, the efficiency, a lot of this is borrowed from where the starting agreement. The open rack is an efficient architecture, so we start with that just in terms of the way, you know, airflow is done and you know, geometry, and then you know, some of the additional efficiencies, at least in kind of some normalized environment, is actually that snapping to grid, and as I mentioned, the fan aggregation and so forth. Combination of, you know, fitting environmentals, you know, in the most efficient manner. So you pack servers in, some amount of aggregation, but not excessive amount of aggregation. Otherwise, it's very simple. This is not elaborate architecture. The thinking is simple. You can go quickly. You can iterate, and people can take it. Some different things. Scale. We actually have proof points. I mean, this is scaled very quickly. So from kind of the prototypes that we've built, you know, we've actually been able to deploy them at scale, so we know that it scales. Now, one of the questions that's come up in the question earlier about granularity, why I was thinking about that is one of the questions is, well, how far can you scale down, right? We have come into, you know, situations where you do have some weight limitations, some power limitations, and possibly even some size limitations. And so we're kind of testing those right now to see how we do that. But architecturally, you know, we have a good scale point there. So we're looking at some kind of half-size things. In fact, right now our deployments are fairly low on the power side. We're not driving the maximum compute density that you could get in specs in which to go. You could do a lot more. So there's a pretty good scale there. Let's see. I don't know. We put it here. I don't know if it relates to scale, but there's some operational things that make scale easy as well. So it's been fairly easy to deploy because of the simplicity of the architecture. So that's a lot to scale.
Yeah, I think that's, again, specifically for the Telco target, where customers have heterogeneous configuration. Not only can we scale within the rack, but we can share a rack with other equipment, for example.
Yeah, and actually, I think we talked about this in Austin, and this is carried forward. We had a slide that said, "Hey, what if we took some other piece of gear and could we bring it in here?" Well, it's a 19-inch rack, so the answer is yeah, we can. And there's a little bit of work, and we've been doing that with some of our partners / competitors / suppliers. It's a murky ecosystem, but that makes it fun. And you can do adaptation. And so yeah, exactly as Matt said. So that also is another way to scale down those. Openness, that's why we're here. So get it out there, publish it, keep it simple, and iterate. I think it's interesting. I think this is a really good time to kind of put this out there, get a foot in the ground, while we collectively listen to requirements, shape requirements, and come up with things. I have no doubt, that the 5 heavyweights sitting here will come up with things that don't fit here. But that's okay, right? It's open, and can we get close and then step towards it? So anyway, that's pretty straightforward. And then this might be the hardest one, the impact. Why do you do something different? I don't know if that's part of impact, but it's always a question, which is how much can you make everything do the same thing? I think we've already seen you can't necessarily. There is not one size or shape that fits every single thing. Taking Open Rack as it is right now and putting it in every instantiation we've been talking about it for the last couple of hours, there are tweakings and tunings. So, I think our main thought here is that the impact of this is to kind of bring this Open Rack, hopefully, into something that can be faster and more widely deployed into telecom networks. That's a hope. And this is a starting point. All right.
I might have missed it. Is this a standard 42U rack, or are you going taller than that?
We actually don't specify the height so we leave that open.
So the spec is focused around the interface between the sleds and the rack. Okay. And so essentially between the sleds and the shelf, that is what holds the sleds. And so you can put many of those in a rack. We have small racks, large racks.
But the answer is yes.
I just saw your comment, scalable up to 80 servers, which is pretty dense, and I was just trying to do a little math.
You gotta get tall to do that, for sure. All right. So, I got through that really fast. So I'm just pause there because now the next section is really to kind of poke around the spec itself and.
Yeah, I guess if I could just essentially what we're running into is 2 servers per view is what it comes out to.
Yeah.
Okay. Oh, so you go to half height.
Yeah.
No. Right now, what we have as a product is in close-up to you.
Yes.
Oh, okay.
So you couldn't have 3 servers, for example, or at least you wouldn't fill.
So for every 2U, you fit 4 servers in.
Right. Yes. Exactly. Yeah.
Yeah, and you'll see that what the spec kind of lays out. And within that, I mean, you could take one of those volumes and slice it up a different way, right? As long as it meets certain points on the edge.
And mean the shelf.
Yes.
You take like one shelf and you can put whatever.
Yeah, and that was the integration that we talked about in taking sort of a mobile edge computing platform that we worked with Jeff Sharman that will just hey, what if we took this thing in, which is a 4U was example, and put that in, and that relatively.
So Andrew, a question, since I haven't been following the Open Rack group much at all, do you see things on a trajectory where we might converge onto a single rack design and only differ at the sled level, or are there such fundamental differences between what the Google and Facebook guys have proposed and what that we're going to be on 2 separate paths?
I don't know the answer. I think a year ago, we saw it being different enough, so let's, we're talking about different depths, right? Different widths are in play. So right off the bat, this was, maybe we can't be as deep as Open Rack, and we need to be 19-inch. But if that fits within, I do think that this ought not to be splintered off to be some little telco thing on the side. So at least it should be part of the same conversation, which is why I know even today it was interesting. We probably ought to be looking at this as a group.
So there's a lot of commonality. There's the equipment bay is both roughly 800 millimeters deep, right? The width of this module is 215 millimeters, roughly 175 millimeters width. open. The electronics in them, are similar in depth and width, the usable space. The fundamental difference between OpenRack is their RU height at 94 millimeters versus 80. And the thing is with this spec is that it aligns with all of the EIA 19 racks. And so you have the option to deploy a heterogeneous set of equipment. And that deployment can take up a portion of the rack or it can take up the full rack. In other words, the shared power aspect doesn't have to span the entire rack. You could say, I'm going to retrofit a 19-inch rack in your data center as long as it's the right depth, right? I can go in and retrofit and I can span shared power across any number of RU slots. For example, you may say, I have this shared power implementation across half my rack, and the other half is going to be legacy equipment. It's quite possible to do that. Right?
You run the power, still run the power rails up the entire rack, or can you just run
You
partial
would
power
probably,
rails?
I mean, for maximum flexibility, you wouldn't. But you could, and
You
again,
could, yeah.
we took as an example, taking something built for that environment is for you. Two choices: treat it as sort of as is, right? In which case you want to put it in that space that is not as bus bars, or make it fit there, make a little change to that thing so that it can plug into that.
There's also some other kind of future opportunities to align. You could, because the OpenRack sled, the 1/3 wide sled, is 94 millimeters. You can actually get 8 of those sleds in 9 RU. So you could actually build trays to put, if you really wanted to use OpenRack sleds, you could build a tray to go into a 19-inch rack. Now, I mean, I haven't done any design, but just looking at it and talking to people, it is possible, right? You could get 9 or 8 in 9U. The beauty about the placement of the, and I haven't looked at this either, but it's possible that you could actually then align to the bus bars as well.
We set this up, there were several influences as we looked originally at OCP and what we had to change to make this work. And we were looking forward to, for example, server boards that had 6 DRAM channels, for example, and needed more width. And so that's one reason why within the 19-inch aperture and looking at that kind of server width became to a problem.
But Bill's absolutely right. A smaller thing can go in a bigger thing.
Yep,
That's
absolutely.
one way to put it. So
I got a question. I guess when we get to this.
It's nice. I don't think you need it. I think it actually fits
So
really well.
the distance between the bus bars, the same as on OpenRack, if you measure that from, say, the center?
No.
So this is more narrow.
Yeah. Well, between the plus and minus is the same, of course, but you're not talking about that. You're talking about between
like
the
between A and B.
Yeah, no,
Right,
it's
because
not.
you get center, so you only have the A and B side.
Because of course we need to put in the same sled on the left and right. Yeah. And so with that being 2 across the
it's the 2 to 3 it can't ask.
Yeah.
So maybe we'll get to some of the pictures here.
Good question.
Yeah.
I'm Brian Overness with Fidelity. I'm actually from
Great. Hi.
Session. So is there a reason why this design was not begun with the OpenRack standard and proposals for change? And so the reason why I'm asking this is that the OpenRack group, the first thing we did was define the standard. And there's been several rack designs that all adhere to that standard. And that standard ensures compatibility in mating between chassis and power, right, and the chassis to the rack itself. And like you guys, it doesn't define how tall or wide or deep a rack is. It only defines the critical components so that to ensure compatibility. So you're using 2 bus bars. Our standard dictates their position must be. Was there a reason why you didn't?
Yeah, I understand your question.
Those initial standards.
I guess the short reason was we were creating a proof point, and the proof point went very fast.
Okay.
And so we didn't consciously. We did look at everything that was there. So we were sort of kind of read mode. We weren't in ourselves in participation with what's been done. We weren't in the community, we were involved yet at that point.
Okay.
And then we thought, well, should we try to come in and bring our voice into this? So there was, and maybe this is wrong, but there's a little bit of a, well, maybe, we're just saying whatever we're saying. I'm not sure if it would have been the right thing. And number two, we wanted to go very, very quickly to the point of step and repeat. Let's go, and prove this out. So we're kind of at the point now where, here we are. I think it's proved, we sort of made it real very quickly. Kind of maybe even surprised ourselves, and working with the ecosystem.
This also went back very far. This is close to 2 years ago. This started.
Well, yeah, but I just mean in terms of some of this also has to do with kind of instantiating that part of it.
So it was a design that was developed outside of OCP,
Yes.
but keeping an eye on what's happening. with
So,
that.
and again, I think, we could go back and say, as an interest, should we have done it differently? Should we have kind of designed, more, in this, and going forward, now that we're sort of in this community, I think would be, might be slightly different. But yes, it was kind of pulled in. So I would say we were in read-only mode for a while, and now we're trying to be in read-write mode.
So, Brian, I think there's a couple of challenges that I've seen with OpenWrap. One is it forces you to a deeper wrap, and so it forces you into a different wrap. So if you can stay with a 19-inch and be compatible with your old equipment, this gives you an option.
Keep in mind that's with bridge wrap.
I understand.
But I think my point is that if there were new requirements from the community to develop a new solution, and you could have brought up to the OpenRack team and said, hey, we have a new challenge and a new application, but the standard prevents us from leveraging it in its current state. It's not unlike what's happening right now with the 48 volt, right? So we're talking about shallower depth there, and then new bus bar design, new power shelf design. So I'm really not trying to be negative. I'm just curious as to where this came from. And because from my perspective, if the more you can leverage the standard, and I'm suggesting that perhaps maybe we should evolve the standard to help you guys along, but the more you can adhere to that standard, the more options you're going to have from a manufacturing and sourcing perspective.
Well, I'll disagree with you on that. Here's why. Today, how many motherboards do you have that go in open? I think there's two, right? There's the two different boards, and the two different new windows that go into it. Maybe three.
So you're suggesting, but I'm not following the point.
Because the
That's
problem.
just an availability problem.
Yeah,
right?
I know, but the problem with OpenWrap today is that the boards that are enabled have to fit in 175 millimeter width, and all of the boards that are built in the industry that power the cloud today, that go in 19-inch rack, use a board that's 200, it's just 6.5 inches. So
what if you just took your board of choice, stick it in a custom chassis
you can't do it.
that works, right?
You can't do it. You can't put it into the existing infrastructure. The trays aren't wide enough.
Yeah, Brian, I think there's two
When-
parts
when
to your
there's-
question.
You're talking, so there's nothing that defines, we're talking about the width of the shelf, right? And we're talking
No.
about
I'm
I'm talking about your opportunity is the width between the vertical posts and the wrap, right? That's your area of innovation from a width perspective.
Sure.
Right. So limit yourself to a chassis or something that's only available today. But I'm not suggesting that you have to fit within that server form factor to be across 2OU highs. What I'm just saying is that if you're developing a chassis to plug into your bus bars, why couldn't the back of that chassis plug into the OpenRack bus bars?
Well, that more like the question I was
Yeah,
asking.
the pitch is wrong. It would
The
work.
pitch
Because
between the bus bars, in my mind, should have matched.
then the sleds would be different, left and right. We'd have to make a left and right sled.
What we're getting to,
Well, only if you require the servers to directly plug into the bus.
No. I mean, if I have identical sleds and they have this much width, right, and they're identical, then that space between them is going to be.
But only because your server is plugging directly into the bus bar, not into a
No,
server.
even if you cable it though, you still have a problem because You'd have to have it, you'd have to have one.
You would have to have a shelf.
Left
that
to center.
that
left to
server.
Some adapter shelf.
Yeah, the shelf wouldn't just be a tray that you slid things into. It would have, similar to the center bus bar fanning out to 3 on the open rack.
Well, this goes
Brian,
back to
the.
But they don't
Back to my
plug
point. So today, if you look at the volume in the industry, it's these 6.5 inch wide boards. Once you enable an enclosure that works with that 6.5 inch board, and you now open up the supply base to dozens of different compute node options.
You're limiting yourself to the current OpenRack standard. What I'm suggesting is, what if you had developed a standard that had 19-inch mounting and maintained the current bus bar configuration, and allow you to take your chassis that you have today, a configuration of an OpenRack that's available today.
If you made a shelf that would fit an open rack, then you could do this because you have enough depth then to come off the
Yeah,
bus
you're
bar.
talking about leveraging a
and
form
split it
factor
out.
that's narrower than the OpenRack standard, right?
But
So
that's
what if you
the
didn't fit? So I don't mean to derail the conversation. I was just curious as to.
But why would I make a rack with that spacing that
Well,
requires
I think-
an adapter to
Wait,
work all
we
the
do,
time?
we do. I think this is an important conversation to have.
Yeah, absolutely.
Right? It's important for us to actually, it's a maximum flexibility, in my mind, maximum flexibility. Right?
I'm trying to get minimum fragmentation,
Yeah,
right?
Well, of course, we got some, there's a 19 inch, and people want to use that. It's like, okay, and then there's 21 or 23, right? And you go, how can I maximize the permutations of, say, these computes, these storage into OpenRack? I think that would be easier than the OpenRack servers, or, the open servers into this. I still have the same, so if you want to put 2 instead of 3, because you don't have the width, it should be able to plug in. The only thing in is the depth, but the depth is not really, it's not what they're after at that point. So use a deeper rack, you could then have a shelf that would do that.
But we had some restrictions.
I mean, in a different implementation.
But maybe Brian, too, I totally. There was a little bit of a balance too between, do you put a constraint at the beginning to say, let's change a couple things, but keep a backwards compatibility, and we didn't. It could have been done, but it would have changed some things. So we left more degrees of freedom. And as Bill said, one of the things was because we were going pretty fast, we were able to leverage a lot of things to just run quickly with the deployment. We're able to get boards, from the market that weren't built for open, half SSI, form factor, standard kind of thing. So we did get some leverage there. But I agree. I mean, it could have been possible that we could have put some more constraints on it and ended up with a little bit of a different answer.
I guess I'm interested, maybe we can talk about this offline. I can't figure out an advantage.
Well, we're talking the process and we're talking the technical. Pure technical, we kind of went with let's borrow all the goodness, but let's let it kind of run, to what it needs to be, because this is a big space, big market, and we felt maybe it's okay. But again, we do want to track, which is why we're here and we're talking. We don't want to be out there with something. Now, maybe the judgment will be we should just be out there, but I think we should. This is worth doing and worth tracking.
bus bar connection.
Is the power button normal for telecom gear? Seems to be something they rarely used.
That's another.
No, that's a button. The left-hand power is a button, and then the other are 3 LEDs. Certainly that can be disabled. It's no problem. Our particular customer likes that, but it's optional.
Yeah.
Most computers, what I was saying before, recently have the button.
Yeah.
But
Yeah.
with the option to disable it.
Mm-hmm. Yeah, exactly. So that fits that. Yeah, and you could argue, for example, should we have specified any of that? I mean, with everything you can question, you specify more or less. You want enough so that things work, and different things will work, but lots of degree of freedom. We talked about the button, so this is your question about the
that shows the
distance
pitch.
between them, so you can see it there. The bus bars themselves, the connections, are the same.
It's just the location.
And that pitch is clearly the pitch of the path width slides.
Yep.
Right.
Yeah. Anything else you want to highlight here? There's more. I mean,
this is
I didn't
very
put
similar.
all the figures here because I figured this specs out there just to give you a flavor of it.
Well, I think actually, if you want to back up a sec, we'll talk about this elsewhere, but this, of course, is the standard. This is an optical blind mate connector that we'll talk about, but that's the data connections, data management connections.
Yeah.
So it's not an
It is not.
It is not. It's a combined blind mate optical connection. So it makes several fibers.
Yeah.
How do you plan to?
And then you go back on the web and get a spec sheet of it and see how it works, and you can how it fans out.
There's an assignment of where
I
management
hate to
should
use
go.
this term, but you think of it as an optical backplane, but
Increasing the bandwidth that over time? Have you
Yes.
thought about how you...
fibers are fibers, absolutely. So in the spec, we do put some, 10 gig and 1 gig in there, but obviously.
The idea is that you could change from lower speed to high speed by changing both ends, but not necessarily the connection between them. There is some flexibility of connection as well, but if you want to maintain interoperability, that is, pull out a sled, put in a sled, then you'd have to agree to some sort of optical connection. If you start moving the connections around, then of course they don't interoperate.
Now that goes back to the thinking of this. It's a rack level deployment, because at the rack level you want to get it all right. So 2 ends are the same thing. How it's configured. This deployment A, deployment B may be different in terms of what's hooked to what, but it would be the same. You want to avoid. That's why I was very careful with the term backplane, right? You think back to chassis and elements built in the backplane. They can be complicated, and especially if you're trying to, this thing plugs in, and people might remember some things where you do e-keying and you figure out what your standard is. You kind of want to avoid all that, which is why you really want to say, look, this is my deployment.
So you say you're 10 gig now, 25, 40, 50, 100, your optics can handle all of that.
Yeah.
Okay.
This is all multimode.
Well, it's actually, like if you go look at the spec for the connector, it's really just a connector that goes in with multiple fibers, 2 per position, and you can get any kind of fan out that you want. And so, depending on what type connector you may want, you can get a different connector.
Yeah, and the connection is broken into 4 sections. Each section is a different.
So we actually have some pictures I was shown. So, it's just colors. Those aren't colors of light. Those are colors of the casing. Sort of you got whatever yellow, red, green, blue, and they go places. And here's an example of a configuration. And you could do any sort of configuration.
Well, one of the things that kind of got me off guard was this is not 2 pair or 2 circuits. There's actually 2 fibers per.
Yes.
So those are actually 4.
Yes, it's 4 fibers.
There's actually 8 fibers coming out of that.
Yeah, exactly. It's
I mean, to everybody, those sections, there's 4 ferrules.
Yeah.
and the ferrules are set up in a table in there as far as in order, again, to make interoperability. But they are 4 ferrules.
And that's kind of, if you,
Now, let me ask an implementation question. In your implementation, do you have a standard Ethernet card with a small jumper going to the Molex connector?
Yeah.
Depending on, so you can have multiple, whatever kind of card I got, and then I just use the.
You mean is there some adaptation to get to that?
Yeah, or does the server? What is it?
It depends on what the server has on it. So in a lot of cases, the server has a native port for that anyway. Then there's a cable between that and running out to the ferrule.
So everybody do a little pigtail or whatever fan out.
But you could build something completely optimized, with no adaptation. We get back to, this is sort of intended to use some off-the-shelf stuff pretty quickly, but there's a lot of room for optimization.
Right, you can back up the file all the way and just have fiber straight out.
Yeah, there's definitely an optimized version to lower cost, but there's also flexibility so that you can move pretty quickly.
Okay.
So,
something you put manually the back end.
Yeah, let's go to the, I mean, that's a working rack, right? I mean, right? So behind, we should have looked, but behind you'd have all those connections, implementing this, and they're all in there, and the idea is that's kind of pre-configured to the topology.
So cables are going to
could you change
switch.
it? Absolutely.
So if you think of these as bays, that is the place where you put a sled, there are cables between the bays and the switches, and those cables can be moved or can be set up and configured. You could add some later. I mean, what we're doing right now is everything that we ship out has a set of cables in there for this optical backplane that you choose, but you can change it.
So if I take the tray out,
Yeah.
No, you're done.
Fiber is.
So if you were swapping, if the thing failed, you swap it, you're done.
So this is, one intention was to simplify the front of the sled. Another one was to reduce the effort, so to speak, of installing and removing sleds. To define where things go instead of, where do I put this cable kind of thing.
So essentially, think about putting you mount your switch, and then all of the ports to the switch would potentially go to a connector on the back, but then only when the server was plugged into that port would come active. But everything is pre-cabled, so you could get 0 servers or 1 server or 2 servers, and then as your capacity needs grew, instead of having to put in a server, run a new cable, test it, that kind of thing, just plug it in, ready to go. That
No,
makes sense.
but then the back itself, so in sort of a mass scale deployment, you really wouldn't want to touch it. That's kind of the whole point. But like in your lab, you might say, let me try to do a topology, so you can just go out and change it. So you can do that, but in a hyperscale deployment, the whole idea is don't touch it, right? And just populate or unpopulate the swamp. Anyway, but again, the spec is that's all how it's actually used.
So this diagram shows really only 4 40 gigabit links per switch on the uplink. Do you have more than that, or is that just an example?
Well, you can do
That's
whatever
an
you
example.
want on the switches. So from the switches, the uplinks are going to, outside the rack. And so you can put in whatever you want. This is, we're trying to be as general as possible here, but of course, it's, I could have drawn more lines going up.
Yeah, no, I was just thinking about consideration for east-west traffic.
Sure.
Yeah, sure. Exactly.
Yeah, and that all comes up. And,
Okay, great.
Yeah.
Yeah, the focus, what we're talking about here, the focus is just in this part.
This is color coded.
And it's just an example.
It's
so
an example.
Whatever you needed.
Yeah. So you don't even have to
As
have
long as you only needed 4. Right. And sometimes you may make those all data plane, and then you may choose to have your 1 gigs cabled off the front in order to get the higher bandwidth out of the server to back. So, you want to have 440 gigs or 400 gigs, and those are pre-cabled, and then you just come back with your.
That's a good point. You do leave front cabling still as an option.
Yes.
Right. Although
yes.
The rear cabling.
It's not right. I mean, it's not pretty for the pictures, but absolutely.
Yeah.
Okay. So realistically, of course, we're not saying what's inside the sled either, right? So that's that functionality. What we're saying is, if you want to automatically connect, here's the connections you can use with that. But you can certainly have whatever you want on the front.
So for that kind of speaks more to the serviceability. So if you want to be able to walk up there, pop it out, pop a new server in, that's all you got to do. There's no take out the cables, make sure the cables are labeled properly, and put in the new one and recable it, and hope they clip the connectors in, those kinds of things, like in, out, or out, in.
So in figure 29, you'd actually have two optical connectors on the back of the tray, on the back of the rack. Would you connect two into the tray, into the sled?
In which one?
Yeah,
No,
full
but in
width,
which
on the
level?
full width.
On the full width, no, we only have a single. And that just has to do with cost reduction. You could.
But you could. But how do you know if you're going to want to put, say you want to take out the 2U compute sled and put a storage sled in there or whatever.
So it's not necessarily, that's
as long
where
as
you
you
get
got
to,
enough ports.
as long as you have enough ports and there's a rack level config, and you do have to think about that.
Right.
So, if you, okay, I think we're almost done.
It's not a you don't want to reconfigure it.
You don't want to do that on the fly in
How
service,
you
yes.
want to deploy first, you cable it up, put it in service.
Yeah, it's interesting. You don't really want to fill up the system with every possibility because it turns out you're burning up ports on the switch.
You need ports on switches.
So we
go multiple.
Is the case that your design really thinks about a storage sled that doesn't allow for hot swapping of components inside?
Not necessarily. And by the way, this could be a long discussion, so we'll just keep it short. Lots of different philosophies there. The one we took just out of our implementation is again, super simple. The unit of granularity is the whole thing. It doesn't have to be that way. You can absolutely design something that has got trays that come out with swapping elements while the rest of it's right. Because the whole, in fact, you can do that kind of accordion thing.
You can think of this as like the storage, if you had a storage controller incorporated, and then you could have a tray that came out just in service.
That's why we have it. Yeah.
But again,
push it back
this is
in.
Do in the network, what granularity do you want there? If you're deploying, 1,000 racks, I mean, maybe you just let a certain number fail and then.
There's definitely how much Kool-Aid you drank.
Yeah,
right.
So, it looks like we kind of cheated here, but just to point out, in the spec, all we did was focus in on a BMC element per node, and that's all we spec. So we kept it pretty simple, and you could even argue about, what does that BMC have to do? Now, there's more that we had in, but again, we kind of kept it streamlined, and I do think there's a lot more management conversation. So don't take this to be, that's not part of it. It's just that we didn't want to package them together. So we did the management plumbing. However, the intention is to be out of band, but all in the same physical. You can say physically in band, and then it all goes to the back, but out of band, and then.
Yeah, this is what needed to be specified so that you could really build something and work in the system.
I would have to find the data find that the real perspective of reality. Yeah, see. Everybody runs out.